Welcome to the Refrigeration and AC Mechanic Red Seal exam practice. This video contains 125 practice questions to help you prepare for your certification exam. Let's begin. This exam covers the following major work activities: performs common occupational skills, performs routine trade activities, plans installation, performs commissioning, and performs maintenance and service. Question 1. A refrigeration mechanic discovers a large refrigerant leak in a below-grade mechanical room. What is the first action that should be taken before attempting any repairs? A. Identify the type of refrigerant to select the correct recovery cylinder. B. Ventilate the space and verify oxygen levels are within the safe range. C. Isolate the leaking section using the nearest service valve on the line. D. Put on insulated gloves and begin tightening the suspected fitting. The correct answer is B. When a large refrigerant leak occurs in a below-grade mechanical room, the immediate priority is life safety. Refrigerants are heavier than air and accumulate in low-lying areas, displacing oxygen and creating an asphyxiation hazard. Before any repair work begins, the space must be ventilated using exhaust fans or by opening doors to allow fresh air circulation. Oxygen levels must then be verified using a calibrated oxygen monitor to confirm the atmosphere is safe for occupancy. Attempting to identify the refrigerant, isolate valves, or tighten fittings before ensuring a breathable atmosphere puts the mechanic at risk of oxygen deprivation, which can cause loss of consciousness within minutes in a confined below-grade space. Question 2. When performing lockout-tagout on a rooftop condensing unit before replacing a compressor contactor, what must be verified after the electrical disconnect is locked out? A. The refrigerant charge level is recorded on the service tag for reference. B. Zero energy state is confirmed by testing at the point of work with a meter. C. The thermostat setpoint has been lowered to prevent a call for cooling. D. The nameplate data matches the replacement contactor specifications exactly. The correct answer is B. After applying a lock and tag to the electrical disconnect of a rooftop condensing unit, the mechanic must verify a zero energy state at the actual point of work. This means using a calibrated voltage meter to test the conductors at the contactor location to confirm no voltage is present. Simply locking the disconnect is not sufficient because stored energy, backfeed from other circuits, or an incorrectly identified disconnect could leave energized conductors at the work location. The verification step is a mandatory part of the lockout-tagout procedure and protects the mechanic from electrical shock or arc flash. Recording refrigerant charge, adjusting thermostats, and checking nameplate data are all valid service tasks, but none of them confirm that the equipment is in a safe, de-energized condition. Question 3. What type of gloves should a refrigeration mechanic wear when handling refrigerant cylinders to prevent frostbite from liquid contact? A. Insulated cryogenic gloves designed for contact with cold liquids. B. Latex examination gloves that provide dexterity for valve operation. C. Leather work gloves rated for abrasion resistance during handling. D. Rubber electrical gloves rated for the voltage of the unit being serviced. The correct answer is A. Insulated cryogenic gloves are the correct choice when handling refrigerant cylinders because liquid refrigerant boils at extremely low temperatures and can cause rapid frostbite on contact with skin. For example, R410A boils at approximately -48 degrees Celsius at atmospheric pressure. If liquid refrigerant escapes from a cylinder valve, hose connection, or fitting, it will flash to a gas and absorb heat from anything it contacts, including exposed skin. Cryogenic gloves are specifically designed to insulate against these extreme cold temperatures. Latex gloves offer no thermal protection and would not prevent frostbite. Leather gloves provide abrasion resistance but lack the thermal insulation needed. Rubber electrical gloves protect against shock but are not designed for cold liquid contact. Question 4. Staff in a walk-in cooler using R744 report headaches and dizziness. A gas detector shows elevated readings. What is the most likely cause? A. The evaporator fan motor is overheating and producing combustion byproducts. B. The walk-in door gasket has failed and is drawing exhaust fumes inside. C. An evaporator coil leak is releasing carbon dioxide that is displacing oxygen. D. The condenser is operating at excessive pressure causing abnormal vibration. The correct answer is C. R744 is the refrigerant designation for carbon dioxide. When staff report headaches and dizziness in a space cooled by an R744 system, and a gas detector shows elevated readings, the most logical conclusion is that the evaporator coil has developed a leak. Carbon dioxide is an odorless, colorless gas that is heavier than air. In an enclosed walk-in cooler with limited ventilation, even a small leak can raise carbon dioxide concentrations to dangerous levels. At concentrations above approximately 3%, carbon dioxide causes headaches, dizziness, and shortness of breath. At higher concentrations it can cause unconsciousness and death by asphyxiation. The fact that the evaporator fan is running means the leaked gas is being circulated throughout the cooler space, distributing the hazard evenly. An overheating fan motor would not explain elevated gas detector readings. A failed door gasket would allow warm air in but not toxic gas. Excessive condenser pressure is unrelated to the symptoms described. Question 5. Why is it essential for a refrigeration mechanic to wear safety glasses with side shields when brazing copper refrigerant lines? A. Copper tubing may contain residual refrigerant oil that splashes during cutting. B. The nitrogen purge flow can blow loose debris toward the worker during brazing. C. Solder fumes condense on standard lenses and reduce the visibility for the task. D. Brazing produces intense light and molten flux that can damage unprotected eyes. The correct answer is D. During brazing of copper refrigerant lines, the oxyacetylene or aracetylene torch produces intense light including infrared radiation that can harm the eyes. Additionally, the brazing process involves flux which becomes molten and can splatter. The brazing alloy itself reaches temperatures well above 600 degrees Celsius and small droplets can be thrown from the joint. Safety glasses with side shields provide essential protection against these hazards from all angles. While residual oil, nitrogen purge debris, and fume condensation are possible minor concerns, none of them represent the primary reason for eye protection during brazing. The combination of intense radiant light and the risk of molten material splatter makes proper eye protection a critical safety requirement for any brazing operation on refrigerant piping. Question 6. Two refrigeration mechanics must work simultaneously on different components of the same chiller system. How should the lockout-tagout procedure be applied? A. Each mechanic applies their own individual lock to the energy isolation device. B. The senior mechanic applies one lock and shares the key with the second worker. C. One mechanic locks out while the other stands by as a dedicated safety watch. D. Both mechanics sign a single tag and the supervisor retains the only lock key. The correct answer is A. When multiple workers must perform maintenance on the same equipment, each worker is required to apply their own individual lock and tag to the energy isolation device. This is known as multi-lock or group lockout. The principle behind individual locks is that each worker maintains personal control over their own safety. The equipment cannot be re-energized until every worker has removed their personal lock, confirming they have completed their work and are clear of the equipment. Sharing a key between workers defeats this protection because one worker could remove the lock while the other is still working on the system. Having one worker stand watch instead of locking out does not provide equivalent protection. Allowing a supervisor to hold the only key removes personal control from the workers who are actually exposed to the hazard. Multi-lock hasps are used when the isolation point only accepts one lock, allowing multiple padlocks to be applied simultaneously. Question 7. Before accessing a rooftop package unit for seasonal maintenance, what fall protection measure must a refrigeration mechanic implement when the roof edge is within 2 meters of the work area? A. Placing pylons around the unit to mark the designated maintenance zone. B. Setting up a guardrail system or using a personal fall arrest harness and lanyard. C. Having a coworker observe from ground level to provide verbal warnings. D. Wearing high visibility clothing so other workers can track the mechanic's position. The correct answer is B. When working within 2 meters of an unprotected roof edge, a refrigeration mechanic must use an engineered fall protection system. The two primary options are installing a temporary guardrail system along the exposed edge, or wearing a personal fall arrest system consisting of a full body harness, lanyard, and suitable anchor point. These measures physically prevent a fall or arrest the worker before they reach the ground. Rooftop HVAC work is one of the most common scenarios where refrigeration mechanics face fall hazards, particularly during seasonal maintenance visits to rooftop package units, condensing units, and cooling towers. Pylons are visual markers only and provide no physical fall prevention. A ground-level observer cannot physically stop a fall. High-visibility clothing improves visibility but offers no fall protection whatsoever. Proper fall protection is a regulatory requirement and is the mechanic's responsibility to implement before beginning rooftop work. Question 9. Why are natural refrigerants such as R290 and R744 becoming more common in new HVAC/R equipment designs? A. They have significantly lower global warming potential than synthetic alternatives. B. They operate at lower pressures which reduces the cost of system components. C. They eliminate the need for oil in the compressor during normal operation. D. They are compatible with all existing copper tubing sizes without modification. The correct answer is A. Natural refrigerants such as R290 propane and R744 carbon dioxide are gaining widespread adoption because they have significantly lower global warming potential compared to traditional synthetic refrigerants like HFCs. R290 has a GWP of 3, and R744 has a GWP of 1, compared to R410A which has a GWP of 2088. As environmental regulations tighten globally and HFC phase-downs accelerate, manufacturers are designing new equipment to use these low GWP alternatives. Refrigeration mechanics must stay current with these emerging technologies because servicing natural refrigerant systems requires different safety considerations. R290 is flammable and requires charge limits and ignition source controls. R744 operates at very high pressures, not lower pressures. Neither refrigerant eliminates the need for compressor oil, and system piping must be specifically sized for each refrigerant's properties. Question 10. When mentoring a refrigeration apprentice on a complex chiller teardown, what approach best supports skill development and knowledge retention? A. Completing the teardown independently while the apprentice observes from a distance. B. Providing the service manual and allowing the apprentice to work without assistance. C. Demonstrating each step and then having the apprentice perform the next one hands-on. D. Describing the entire procedure verbally before starting any of the physical work. The correct answer is C. The most effective mentoring approach for a complex hands-on task like a chiller teardown is a demonstrate-then-practice method. The journey person performs a step while explaining the technique, reasoning, and safety considerations, then the apprentice performs the subsequent step under supervision. This approach combines visual learning with immediate hands-on practice, which significantly improves skill development and knowledge retention. The apprentice gains confidence through guided experience while the journey person can provide real-time feedback and correction. Simply observing from a distance limits tactile learning and engagement. Handing over a manual without guidance leaves the apprentice without the benefit of the journey person's practical experience and trade knowledge. Describing the entire procedure verbally before starting overloads the apprentice with information that is difficult to retain without the physical context of performing each step. Question 11. When using a flaring tool on 3/8" soft copper tubing for a refrigerant connection, what must be done to the tubing end before forming the flare? A. Ream the inside edge to remove burrs and ensure a smooth seating surface. B. Apply flux paste to the interior wall to promote proper metal adhesion. C. Score the tubing exterior with a file to allow the flare nut to grip. D. Anneal the tubing end with a torch until it reaches a dull cherry red. The correct answer is A. Before forming a flare on soft copper tubing, the inside edge must be reamed to remove any burrs left from the cutting process. Burrs on the inner edge of the tubing can prevent the flare from seating properly against the fitting, resulting in a refrigerant leak. The reaming tool, often built into the tubing cutter, smooths the interior surface so the flared end creates a uniform, gas-tight seal when compressed between the flare nut and the fitting body. Applying flux is a brazing preparation step and is not used for flare connections. Scoring the exterior would damage the tubing and compromise its integrity. Annealing is unnecessary because the tubing is already soft-drawn copper, which is specifically manufactured to be malleable enough for flaring without additional heat treatment. Question 12. During refrigerant recovery from a commercial system, the recovery machine shuts off but the system gauge still reads 103 kilopascals. What is the correct next step? A. Open the liquid line valve wider to increase the flow rate into the recovery tank. B. Disconnect the recovery hoses and verify the charge weight on a digital scale. C. Switch the recovery machine to high-pressure mode and resume the operation. D. Allow the system to equalize and restart the recovery machine to continue pulling. The correct answer is D. When a recovery machine shuts off during the process but the system still shows residual pressure, refrigerant remains trapped in oil, within system components, or dissolved in areas that were not fully evacuated. The correct procedure is to allow the system pressure to equalize, giving trapped refrigerant time to migrate out of the oil and dead-end passages, then restart the recovery machine to continue pulling until the required vacuum level is reached. Recovery must continue until the system reaches the mandated final recovery vacuum, which varies by refrigerant type and system charge size. Opening valves wider will not address trapped refrigerant. Disconnecting at 103 kilopascals means leaving recoverable refrigerant in the system, which violates environmental regulations. There is no separate high-pressure mode on standard recovery machines for this situation. Question 13. What does a micron gauge measure during the evacuation process of a refrigeration system? A. The temperature of residual moisture inside the system piping. B. The depth of vacuum achieved inside the system in microns of mercury. C. The weight of refrigerant remaining in the system after recovery. D. The flow rate of air being removed by the vacuum pump per minute. The correct answer is B. A micron gauge measures the depth of vacuum inside a refrigeration system in microns of mercury, microns Hg. 1 micron equals 1,000th of a millimeter of mercury, which provides a much more precise measurement than standard compound gauges that read in inches of mercury. During evacuation, the technician monitors the micron gauge to verify that the system has reached the required vacuum level, typically 500 microns or lower for most refrigeration applications. This deep vacuum ensures that moisture and non-condensable gases have been removed from the system before charging with refrigerant. The micron gauge does not directly measure temperature, refrigerant weight, or air flow rate, though the vacuum level it reads is directly related to the boiling point of any moisture present in the system. Question 14. A technician connects a vacuum pump to a system for evacuation. Which practice ensures the fastest pull down to 500 microns? A. Using large diameter short hoses connected directly to system service ports. B. Using the longest available hoses to keep the pump away from the work area. C. Connecting the vacuum pump through the manifold gauge set center hose. D. Running the pump with the gas ballast valve closed from the very start. The correct answer is A. The speed of evacuation is heavily influenced by the conductance of the connecting hoses between the vacuum pump and the system. Large diameter, short hoses connected directly to the system service ports minimize flow restriction and pressure drop, allowing the pump to pull the deepest vacuum in the shortest time. Routing the vacuum pump through a manifold gauge set introduces additional restrictions from the small internal passages of the manifold valves and the Schrader valve depressors. Long hoses increase resistance and slow the evacuation considerably, especially at deep vacuum levels where molecular flow dominates. The gas ballast valve should initially be opened during early pump down to help purge moisture from the pump oil, then closed as the vacuum deepens, so closing it from the start is not correct practice either. Question 15. When using a clamp-on ammeter to check the running amperage of a compressor motor, where should the clamp be placed for an accurate reading? A. Around the entire cable bundle containing all phase conductors together. B. Around the ground wire connected to the compressor chassis terminal. C. Around the control circuit wiring between the contactor and thermostat. D. Around a single conductor of the power supply wiring to the compressor. The correct answer is D. A clamp-on ammeter must be placed around a single conductor to obtain an accurate current reading. The instrument works by measuring the magnetic field generated by current flowing through the conductor. If the clamp is placed around multiple conductors carrying current in opposite directions, such as the full cable bundle containing supply and return conductors, the magnetic fields cancel each other out and the meter reads near zero. Clamping around a ground wire would only show current if there were a ground fault, and the reading would not represent normal operating amperage. Placing the clamp on control circuit wiring would measure the low current control signal, not the compressor motor running current. Measuring a single-phase conductor provides the actual running load amperage, which can then be compared to the compressor nameplate rated load amps and maximum continuous amps. Question 16. On a piping and instrumentation diagram for a refrigeration system, what does a diamond-shaped symbol typically represent? A. An instrument or measuring device such as a pressure gauge. B. A pressure relief device such as a spring-loaded safety valve. C. A manual shutoff valve in the refrigerant liquid line. D. A filter dryer installed in the liquid line after the condenser. The correct answer is A. On piping and instrumentation diagrams, P and IDs, the diamond-shaped symbol is the standard representation for instruments and measuring devices. Inside or adjacent to the diamond, letter codes identify the type of measurement and function. For example, PI indicates a pressure indicator, gauge, TI indicates a temperature indicator, and PE indicates a pressure element or transmitter. This convention follows established drafting standards used across the H.VAC/our industry. Pressure relief devices are typically shown as valve symbols with a specific designation. Manual shutoff valves use standard valve symbols such as gate or ball valve representations. Filter dryers have their own unique symbol that typically resembles a cylindrical housing with inlet and outlet connections. Question 17. A wiring schematic shows a compressor contactor coil connected through a series circuit with a high-pressure switch, low-pressure switch, and thermostat. What happens if the high-pressure switch opens? A. The thermostat takes over control and keeps the compressor running normally. B. The low-pressure switch bypasses the fault and maintains compressor operation. C. The compressor switches to reduced capacity mode until pressure normalizes. D. The contactor coil de-energizes and the compressor shuts down immediately. The correct answer is D. In a series safety circuit, all switches must be closed for current to flow through the contactor coil. When the high-pressure switch opens due to excessive discharge pressure, it breaks the circuit path and the contactor coil de-energizes. Without the coil energized, the contactor contacts open and disconnect power to the compressor motor, shutting it down. This is a fundamental safety design principle. Placing safety switches in series ensures that any single safety condition can independently stop the compressor. The thermostat and low-pressure switch cannot bypass or compensate for the open high-pressure switch because there is no alternate current path in a series circuit. The compressor does not have a reduced capacity mode activated by safety switch operation. The system remains off until the high-pressure condition is resolved and the switch resets. Question 18. A technician must replace a burned-out compressor in a walk-in cooler that uses R404A. When planning the job sequence, which task must be completed before pulling the system into a vacuum? A. Recovering the remaining refrigerant charge and replacing the liquid line dryer. B. Charging the new compressor with the specified oil quantity for the application. C. Wiring the new compressor motor terminals and verifying rotation direction. D. Installing the new filter dryer and confirming all connections are leak-tight. The correct answer is A. Before a system can be evacuated with a vacuum pump, all refrigerant must first be recovered from the system, and any contaminated components such as the liquid line filter dryer must be replaced. In a burned-out compressor scenario, acid contamination from the motor winding failure will have spread through the system, making dryer replacement mandatory. The recovery must be completed to meet environmental regulations and to allow the system to be opened safely for component replacement. Once the old compressor is removed, the new compressor installed, the replacement dryer installed, and all brazed and mechanical connections completed and confirmed leak-free, then the system can be evacuated. Charging with oil, wiring motor terminals, and verifying rotation are tasks that occur after evacuation and during the commissioning phase, not before vacuum pull-down. Question 19. What information is found on a refrigerant cylinder label that a technician must verify before connecting it to a system being charged? A. The maximum ambient temperature at which the system condenser can operate. B. The refrigerant type designation and whether the cylinder is liquid or vapor rated. C. The required superheat setting for the specific evaporator being serviced. D. The compressor manufacturer recommended oil charge in fluid ounces. The correct answer is B. Before connecting a refrigerant cylinder to any system, the technician must verify the cylinder label to confirm the correct refrigerant type designation matches the system nameplate requirements. Using the wrong refrigerant can cause catastrophic system failure, dangerous pressures, oil incompatibility, and environmental violations. The label also indicates whether the cylinder is rated for liquid or vapor withdrawal, which determines the proper orientation during charging. Additional label information includes the net weight, tare weight, maximum fill capacity, and pressure temperature data. The maximum condenser ambient temperature is found on the condensing unit nameplate or manufacturer specifications, not the refrigerant cylinder. Superheat settings are determined from system design data and manufacturer charging charts. Oil charge quantities are listed in the compressor or system manufacturer documentation. Question 20. Before brazing a new evaporator into an existing walk-in freezer, what work site preparation step addresses the fire risk from the brazing torch? A. Removing all refrigerant labels from nearby cylinders to prevent heat damage. B. Opening all doors and windows in the building to increase natural ventilation. C. Wrapping the torch tip in wet cloth between each braze to prevent tip overheating. D. Positioning a fire extinguisher within reach and using a heat shield behind joints. The correct answer is D. When brazing in an existing structure, fire prevention is a critical work site preparation requirement. The technician must position an appropriate fire extinguisher within immediate reach and place a heat-resistant shield or fire blanket behind the joints being brazed to protect combustible materials such as insulation panels, wood framing, plastic vapor barriers, and stored products. Walk-in cooler and freezer panels often contain combustible foam insulation that can ignite if exposed to direct torch flame or radiant heat. Removing refrigerant labels does not address the actual fire risk from the torch. Opening doors and windows may help with ventilation but does not protect nearby combustible materials from direct flame contact. Wrapping the torch tip in wet cloth is not a recognized fire safety procedure and could create a steam hazard. Question 21. When transporting a 57 kg cylinder of R410A refrigerant in a service vehicle, what is required to prevent a safety hazard? A. Laying the cylinder on its side with the valve facing the rear of the vehicle. B. Removing the valve cap to allow pressure equalization during temperature changes. C. Securing the cylinder in an upright position with the protective cap installed. D. Wrapping the cylinder in insulation blankets to prevent temperature fluctuations. The correct answer is C. Refrigerant cylinders must be transported in an upright position and properly secured to prevent them from rolling, falling, or shifting during vehicle movement. The protective valve cap must remain installed during transport to protect the cylinder valve from impact damage that could cause a catastrophic release of high-pressure refrigerant. R410A operates at significantly higher pressures than many other common refrigerants, making valve protection especially important. A damaged valve on a full cylinder can turn it into a dangerous projectile. Laying cylinders on their side increases the risk of liquid refrigerant entering the valve, and having the valve face any direction without the cap exposes it to impact. Removing the valve cap eliminates the primary protection against valve damage. Insulation blankets do not address the physical impact and containment hazards associated with unsecured cylinder transport. Question 22. Why must copper tubing be kept capped or plugged during storage before installation on a refrigeration job site? A. To prevent moisture, dirt, and contaminants from entering the tubing interior. B. To prevent the copper from oxidizing and changing color on the exterior surface. C. To maintain the factory-applied protective oil coating inside the tubing walls. D. To keep insects and rodents from nesting inside the tubes during warm weather. The correct answer is A. Copper tubing used in refrigeration systems must be kept sealed with caps or plugs during storage and until the moment of installation to prevent moisture, dirt, metal filings, and other contaminants from entering the tubing interior. Even small amounts of moisture inside a refrigeration system can freeze at expansion devices, cause acid formation when combined with refrigerant and oil at high temperatures, and lead to copper plating on compressor-bearing surfaces. Dirt and debris can clog metering devices, damage compressor valves, and contaminate the lubricating oil. While exterior oxidation can occur, it does not affect the internal cleanliness that is critical for system operation. Refrigeration-grade copper tubing is cleaned and dehydrated at the factory, so maintaining that sealed condition until installation is essential for system reliability and longevity. Question 23. A technician is preparing to recover refrigerant from a large commercial chiller in a mechanical room. What ventilation-related step must be completed before starting the recovery process? A. Sealing all ventilation openings to prevent refrigerant from reaching occupied spaces. B. Verifying that the mechanical room ventilation system is operational and adequate. C. Installing a portable dehumidifier to reduce moisture levels in the work area. D. Placing dry ice near the floor drains to freeze and block any escaping refrigerant. The correct answer is B. Before performing refrigerant recovery in an enclosed mechanical room, the technician must verify that the room ventilation system is operational and provides adequate air circulation. Refrigerant vapors are heavier than air and can displace oxygen at floor level, creating an asphyxiation hazard if ventilation is insufficient. Many refrigerants are odorless or have only faint odors, making it difficult to detect a dangerous concentration without proper monitoring equipment. Adequate ventilation ensures that any incidental refrigerant released during hose connections or disconnections is diluted and exhausted safely. Sealing ventilation openings would trap any released refrigerant in the room, increasing the danger. A dehumidifier does not address the vapor displacement hazard. Dry ice placed near drains is not a recognized safety procedure and would add carbon dioxide to the confined space, worsening the oxygen displacement risk. Question 24. When brazing copper refrigerant tubing, why is a continuous flow of dry nitrogen passed through the inside of the tubing during the brazing process? A. To cool the braze joint quickly and produce a stronger metallurgical bond. B. To pressurize the tubing and detect any leaks at the joint immediately. C. To prevent copper oxide scale from forming on the interior tube surfaces. D. To push residual moisture out of the tubing before the joint is sealed. The correct answer is C. Flowing dry nitrogen through the tubing during brazing displaces oxygen from the interior of the pipe, preventing copper oxide scale from forming on the heated interior surfaces. When copper is heated to brazing temperatures in the presence of oxygen, heavy black copper oxide forms and flakes off into the system. These oxide particles contaminate the refrigerant oil, clog metering devices such as thermostatic expansion valves and capillary tubes, score compressor cylinders and bearing surfaces, and can cause system blockages. The nitrogen flow must be maintained at a low, continuous rate throughout the entire brazing operation. The purpose is not to cool the joint, as rapid cooling can actually weaken a braze. The nitrogen flow rate used during brazing is far too low to serve as a pressure test. While nitrogen is dry, the primary purpose during brazing is specifically to displace oxygen and prevent oxidation, not to remove moisture. Question 25. What gas is used to perform a standing pressure test on a newly installed refrigeration system before evacuation? A. Compressed air from a standard shop compressor with a moisture separator. B. Carbon dioxide from a regulated cylinder connected to the high side. C. Oxygen-free dry nitrogen from a regulated cylinder with a pressure limiter. D. A trace charge of the system refrigerant mixed with atmospheric air. The correct answer is C. Oxygen-free dry nitrogen, OFN, is the standard gas used for standing pressure tests on refrigeration systems. Nitrogen is inert, dry, and readily available in high-pressure cylinders that can deliver the pressures needed for thorough leak testing. A pressure regulator is used to control the test pressure, and a pressure relief device or limiter must be installed to prevent exceeding the maximum allowable working pressure of the system components. Compressed air contains moisture and contaminants that would remain in the system and cause problems during operation. Carbon dioxide, while sometimes used in very specific applications, can solidify at low temperatures and is not the standard test medium. Using refrigerant mixed with air creates a potentially flammable mixture with some refrigerant types and is environmentally wasteful. The nitrogen must be oxygen-free to eliminate any risk of combustion if a leak occurs near an ignition source during the test. Question 26. During a triple evacuation procedure, what is done between each vacuum pull-down cycle? A. The vacuum pump oil is drained and replaced with fresh oil to remove absorbed moisture. B. The system is heated with external heat sources to drive out moisture from metal surfaces. C. The micron gauge is recalibrated against a known reference to verify accuracy. D. The system is broken to a slight positive pressure with dry nitrogen before re-evacuating. The correct answer is D. In a triple evacuation procedure, the system is pulled down to a deep vacuum, then the vacuum is broken by introducing dry nitrogen to a slight positive pressure, and the process is repeated for a total of 3 evacuation cycles. Breaking the vacuum with nitrogen between cycles serves a critical purpose. It sweeps moisture that has migrated out of hard-to-reach areas, oil-logged passages, and metal surfaces during the vacuum phase, diluting the water vapor concentration. Each subsequent vacuum pull-down then removes this nitrogen along with the moisture it has absorbed. This is more effective than a single deep vacuum pull because it physically purges moisture rather than relying solely on boiling it off under vacuum. Changing vacuum pump oil between each cycle is unnecessary and wastes time, though oil changes may be warranted after extended evacuation of heavily contaminated systems. External heating may help in some situations but is not the defining step between cycles. Micron gauge recalibration between cycles is not part of the standard procedure. Question 27. A technician charges an R410A split system with refrigerant after evacuation. The outdoor temperature is 25 degrees Celsius, but the system shows higher than expected suction pressure and lower than expected superheat. What is the most likely cause? A. The indoor air filter is severely restricted and reducing evaporator airflow. B. The metering device is stuck partially closed and restricting refrigerant flow. C. The compressor suction valve is leaking internally and reducing pumping capacity. D. The system has been overcharged with refrigerant beyond the required amount. The correct answer is D. Higher than expected suction pressure combined with lower than expected superheat is the classic symptom pattern of an overcharged system. When excess refrigerant is added, more liquid refrigerant floods the evaporator than the coil can fully evaporate at the current heat load. This results in liquid refrigerant persisting further along the suction line, which lowers superheat because the refrigerant temperature stays closer to its saturation point. The excess refrigerant mass in the evaporator raises the suction pressure above normal operating values. A restricted air filter would reduce airflow across the evaporator, causing low suction pressure and potentially low superheat due to poor heat absorption, but the suction pressure would be low rather than high. A partially closed metering device restricts refrigerant flow to the evaporator, causing low suction pressure and high superheat. A leaking compressor suction valve would show high suction pressure but would typically show high superheat because the compressor cannot pull refrigerant through the evaporator effectively, so the distinction with overcharging is the superheat reading. Question 28. Why must R410A refrigerant be charged into a system in the liquid phase from the cylinder? A. R410A is a zeotropic blend that will fractionate if charged as a vapor. B. Liquid charging prevents the cylinder from freezing during the transfer process. C. Liquid refrigerant flows faster through charging hoses than vapor does. D. Charging as vapor causes excessive moisture to enter the system piping. The correct answer is A. R410A is a near-azeotropic blend of R32 and R125 inches of 50/50 composition by weight. Although it behaves nearly like a single-component refrigerant, it has a slight temperature glide and can fractionate if charged as a vapor. Fractionation occurs when the more volatile component of the blend evaporates preferentially from the cylinder, meaning the vapor leaving the cylinder has a different composition than the remaining liquid. If charged as vapor, the system would receive a refrigerant mixture with incorrect proportions, altering the system operating pressures, capacity, and efficiency from the design values. Liquid charging ensures that both components leave the cylinder in the same 50/50 proportion as manufactured. Cylinder freezing, flow speed, and moisture entry are not the reasons for liquid phase charging. The liquid is typically metered into the low side through a metering device or allowed into the high side directly during charging to maintain safe compressor operation. Question 29. When performing field wiring between an indoor air handler and an outdoor condensing unit on a residential split system, what must be verified after completing the wiring connections? A. That the wire gauge matches the paint color coding used by the equipment manufacturer. B. That the thermostat display shows the correct outdoor ambient temperature reading. C. That the power supply voltage exceeds the nameplate rating by at least 10%. D. That the wire terminations match the wiring diagram and connections are mechanically secure. The correct answer is D. After completing field wiring between components of a split system, the technician must verify that all wire terminations correspond to the correct terminals as shown on the equipment wiring diagram and that all connections are mechanically tight and secure. Incorrect wiring can cause compressor damage from reverse rotation on three-phase units, contactor chatter, blown control fuses, or complete system failure. Loose connections create high resistance points that generate heat, which can melt wire insulation, damage terminal blocks, and create fire hazards. Each wire must be on the correct terminal as designated by the manufacturer schematic, and all terminal screws, lugs, or connectors must be properly torqued. Wire gauge is determined by ampacity requirements and code, not by color coding. Thermostat outdoor temperature display is not a wiring verification method. Power supply voltage should be within the manufacturer specified range, typically within plus or minus 10% of nameplate, not exceeding it by 10%. Question 30. What is the primary reason for insulating the suction line on a direct expansion refrigeration system? A. To protect the copper tubing from physical damage during routine maintenance work. B. To prevent condensation on the cold pipe surface and maintain system cooling capacity. C. To reduce vibration noise transmitted from the compressor through the suction piping. D. To match the appearance of the liquid line insulation for a professional installation. The correct answer is B. The suction line carries cold, low-pressure refrigerant vapor from the evaporator back to the compressor. Without insulation, the cold pipe surface causes moisture in the surrounding air to condense on the exterior, which can lead to water dripping onto ceilings, walls, equipment, and stored products. This condensation also represents unwanted heat gain into the suction line, which reduces the cooling capacity of the system because the refrigerant absorbs heat from the ambient air instead of from the conditioned space. Proper closed-cell insulation with sealed joints and a vapor barrier prevents both condensation formation and thermal heat gain, maintaining system efficiency and preventing water damage. Physical protection is a secondary benefit but not the primary purpose of suction line insulation. Vibration dampening is addressed through vibration eliminators and flexible connectors, not pipe insulation. Matching the appearance of the liquid line is not a technical requirement since liquid lines are not always insulated in standard direct expansion systems. Question 31. When performing a residential cooling load calculation, what must be determined first before selecting equipment capacity? A. The brand and model number of the condensing unit that best fits the available budget. B. The preferred color of the indoor air handler to match the mechanical room decor. C. The distance from the nearest electrical supply house to the planned installation site. D. The total heat gain from building envelope, occupants, lighting, and equipment sources. The correct answer is D. Before selecting equipment capacity, a mechanic must first determine the total heat gain of the space. This involves calculating sensible and latent heat loads from all contributing sources, the building envelope, walls, roof, windows, infiltration, internal gains from occupants, lighting fixtures, and any heat-generating equipment. These individual loads are summed to establish the total cooling requirement in B.T.U/H or kilowatts. Only after this comprehensive load calculation is completed can appropriate equipment be sized to match the actual demand. Undersizing leads to insufficient cooling and excessive run times, while oversizing causes short cycling, poor humidity control, and wasted energy. The load calculation is the foundational step in H.VAC/our system design. Question 32. What characteristic makes our 410A different from our 22 when selecting system components? A. Our 410A operates at significantly lower pressures than our 22 across all conditions. B. Our 410A requires the same components and pressure ratings as our 22 systems. C. Our 410A operates at significantly higher pressures than our 22 across all conditions. D. Our 410A is a single compound refrigerant while our 22 is a blended mixture. The correct answer is C. Our 410A operates at approximately 50 to 60% higher pressures than our 22 at equivalent saturation temperatures. For example, at a condensing temperature of 38 degrees Celsius, our 410A has a saturation pressure near 2,340 kilopascals compared to approximately 1,450 kilopascals for our 22. This higher operating pressure means that components designed for our 22 cannot simply be reused for our 410A systems. Compressors, condensers, evaporators, service valves, pressure switches, and copper tubing must all be rated for the higher pressures. Using our 22 rated components with our 410A can result in catastrophic failure. Additionally, our 410A is actually a near-azeotropic blend of our 32 and our 125, while our 22 is a single compound refrigerant. Question 33. When determining the placement of a rooftop condensing unit, what factor is most critical to system performance? A. Installing the unit directly above the electrical panel to minimize wire run length. B. Placing the unit on the south-facing edge of the roof for maximum sun exposure. C. Positioning the unit at the lowest point on the roof to simplify condensate drainage. D. Ensuring adequate clearance around the coil for unrestricted condenser airflow. The correct answer is D. Adequate clearance around the condenser coil is the most critical placement factor for maintaining proper system performance. A condensing unit requires unrestricted airflow to reject heat efficiently. If the unit is placed too close to walls, parapets, adjacent equipment, or other obstructions, the discharged warm air can recirculate back through the condenser coil. This recirculation raises the condensing temperature and pressure, reducing system capacity, increasing energy consumption, and potentially triggering high-pressure safety cutouts. Manufacturer specifications typically require minimum clearances of 300 to 600 mm on the sides and 1,200 mm or more above the unit. Proper placement planning accounts for prevailing wind direction, proximity to exhaust vents, and structural load capacity of the roof. Question 34. When performing a material takeoff for a split system installation, what must be accounted for in the refrigerant line sizing? A. The color preference of the building owner for the line set insulation jacket. B. The vertical rise and total equivalent length including fittings and bends in the line set. C. The resale value of the leftover copper tubing after the installation is complete. D. The number of service technicians who will be working on future maintenance calls. The correct answer is B. Refrigerant line sizing must account for the vertical rise between the indoor and outdoor units as well as the total equivalent length of the piping run, which includes the measured distance plus the equivalent length added by fittings and bends. Each elbow, T, and coupling adds friction that is expressed as an equivalent length of straight pipe. A greater vertical rise increases the static head that the compressor must overcome to push liquid refrigerant and also affects oil return in the suction line. If the suction line is undersized for a long vertical run, refrigerant velocity drops below the minimum needed to carry oil back to the compressor, leading to oil logging and eventual compressor failure. Manufacturer tables specify line sizes based on capacity, line length, and elevation difference. Question 35. What is the primary purpose of performing a manual J calculation during H.VAC/our system design? A. To determine the correct heating and cooling equipment capacity for the building. B. To establish the monthly energy bill the homeowner should expect to pay. C. To calculate the total weight of ductwork needed for the air distribution system. D. To identify the required number of service visits during the first year of operation. The correct answer is A. A manual J calculation is the industry standard procedure for determining the heating and cooling loads of a residential building. It considers factors such as building orientation, insulation levels, window area and type, infiltration rates, occupant count, internal heat gains, and local climate design conditions. The resulting load values in B.T.U/H represent the amount of heating and cooling capacity the system must deliver to maintain comfort under peak conditions. This calculation directly informs equipment selection and prevents the common problem of oversizing, which leads to short cycling, poor humidity removal, and higher installation costs. It also prevents undersizing, which results in the inability to maintain setpoint temperatures during extreme weather. Manual J is referenced in most building codes as the accepted method for residential load calculations. Question 37. When selecting a defrost timer for a medium temperature refrigeration system, what factor determines the number of defrost cycles per day? A. The total number of light fixtures installed inside the refrigerated display case. B. The ambient humidity level and frequency of door openings at the evaporator location. C. The phase voltage of the building's incoming electrical service connection. D. The length of the warranty offered by the defrost timer manufacturer on the unit. The correct answer is B. The number of defrost cycles required per day is primarily determined by the moisture load on the evaporator, which depends on ambient humidity and how frequently the cooler door is opened. Each time the door opens, warm moist air enters and the moisture condenses and freezes on the evaporator coil surface. In a high-traffic application such as a busy convenience store cooler, the evaporator accumulates frost rapidly and may need 4 to 6 defrost cycles per day. A low-traffic application in a dry climate may need only 2 cycles. Excessive defrost cycles waste energy and raise product temperature unnecessarily, while insufficient defrost cycles allow ice buildup that blocks airflow, reduces heat transfer, raises suction pressure drop across the coil, and eventually causes the system to lose capacity. The mechanic must assess site conditions during the planning phase to select and program the appropriate defrost schedule. Question 38. Why should a thermostat sensing element in an HVAC system not be placed on an exterior wall? A. Exterior walls are reserved for mounting condensing units and compressor assemblies. B. Building codes prohibit mounting any electrical devices on exterior-facing wall surfaces. C. Temperature at an exterior wall does not represent the average condition of the space. D. Thermostats on exterior walls create interference with wireless communication signals. The correct answer is C. A thermostat sensing element placed on an exterior wall will be influenced by heat gain or heat loss through that wall, causing it to read a temperature that does not accurately represent the average condition of the conditioned space. In winter, the exterior wall surface is colder than the room average, so the thermostat calls for heat longer than necessary, overheating the space and wasting energy. In summer, the wall may be warmer due to solar gain, causing the cooling system to run excessively. Proper thermostat placement is on an interior wall, approximately 1.5 meters above the floor, away from direct sunlight, supply air registers, doorways, and heat-producing appliances. This location provides a reading that best represents occupant comfort conditions and ensures the control system responds appropriately to actual space temperature changes. Question 39. When performing a control system material takeoff for a multi-zone rooftop unit, what must be included for each zone beyond the thermostat? A. A zone damper with actuator, thermostat wiring, and a transformer if required by the zone board. B. A dedicated condensing unit for each zone to provide independent temperature regulation. C. An individual refrigerant circuit with separate expansion valve for each controlled zone. D. a standalone variable frequency drive on the supply fan serving each individual zone. The correct answer is A. In a multi-zone system served by a single rooftop unit, each zone requires a motorized zone damper with an actuator to modulate or open and close airflow to that zone. Each zone also needs a thermostat or temperature sensor connected by control wiring back to the zone control board. If the zone board operates at 24 volts AC and the zones are located far from the air handling unit, individual transformers may be required to maintain adequate voltage at each zone panel. The zone dampers open when the thermostat calls for conditioning and close when the setpoint is satisfied, directing airflow only where it is needed. The material takeoff must include the damper, actuator, thermostat, control wiring with appropriate gauge for the run length, transformer, mounting hardware, and any relays or end switches. Missing components from the takeoff leads to project delays and return trips to the supply house. Question 40. When planning the control wiring for a packaged rooftop unit, what is the purpose of including a low ambient lockout control in the design? A. To increase compressor speed when outdoor temperatures drop below the design point. B. To activate the backup electric heating elements when the condenser fan stalls. C. To prevent compressor operation when outdoor temperature is too low for safe operation. D. To switch the reversing valve from cooling mode to heating mode during cold weather. The correct answer is C. A low ambient lockout control is included in the control wiring to prevent the compressor from operating when the outdoor ambient temperature falls below a safe threshold for cooling operation. When outdoor temperatures are very low, the condensing pressure drops significantly, which reduces the pressure differential across the expansion device. This can result in insufficient refrigerant flow to the evaporator, liquid refrigerant flooding back to the compressor, poor oil return, and potential compressor damage from liquid slugging or oil dilution. The lockout sensor is typically wired in series with the compressor contactor control circuit and opens the circuit when ambient temperature drops below the manufacturer-specified minimum, usually around 10 to 15 degrees Celsius for standard cooling equipment. This control must be specified during the planning phase and included in the wiring diagram. Question 41. What is the first step when analyzing the energy efficiency of an existing HVAC/R system for a potential retrofit? A. Ordering replacement parts from the manufacturer before assessing current performance. B. Disconnecting the existing system and removing it to weigh the individual components. C. Documenting the current system operating parameters and comparing them to design values. D. Installing a new digital thermostat to see if the existing system responds correctly. The correct answer is C. The first step in analyzing energy efficiency for a retrofit is to document the current operating parameters of the existing system and compare them to the original design values or manufacturer specifications. This includes measuring suction and discharge pressures, superheat, subcooling, supply and return air temperatures, airflow volume, amperage draw, and run times. By comparing these actual measurements to what the system should be delivering at the current conditions, the mechanic can identify specific performance deficiencies. For example, if the system was designed to deliver 35 kilowatts of cooling but measurements show it is only achieving 28 kilowatts, there is a quantifiable efficiency loss. This baseline data informs the retrofit scope, helps justify the investment to the building owner, and provides a benchmark to verify improvement after the retrofit is completed. Question 42. When determining retrofit requirements for converting an R22 system to R454B, what component compatibility issue must be evaluated? A. Whether the existing ductwork color matches the new refrigerant identification labels. B. Whether the existing system oil is compatible with the replacement refrigerant chemistry. C. Whether the building owner prefers a scroll compressor over a reciprocating model. D. Whether the original installation contractor is still available to perform warranty work. The correct answer is B. Oil compatibility is a critical evaluation when retrofitting refrigerants. R22 systems typically use mineral oil or alkylbenzene oil, but R454B requires polyester oil for proper miscibility and lubrication. If the existing mineral oil is not removed and replaced, it will not mix adequately with R454B and can accumulate in the evaporator, reducing heat transfer and starving the compressor of lubrication. The mechanic must determine if a simple oil change is sufficient or if multiple flushes are needed to reduce residual mineral oil to an acceptable concentration, usually below 5%. In some cases, the compressor may need replacement if it cannot be adequately flushed. Additionally, the existing expansion device, filter dryer, and gasket materials must be checked for compatibility with our 454B, which has different pressure temperature characteristics and is mildly flammable, classified as A2 liters. This evaluation is essential to determining the full scope and cost of the retrofit. Question 51. During a condensing unit retrofit, what is the correct procedure for replacing an older fixed orifice metering device with a thermostatic expansion valve? A. Install the TXV upstream of the existing fixed orifice and leave both devices in the circuit. B. Mount the TXV sensing bulb on the liquid line entering the evaporator inlet connection. C. Set the TXV superheat to 0 degrees before connecting it to the evaporator coil. D. Remove the fixed orifice, braze in the TXV body, and mount the sensing bulb at the evaporator outlet. The correct answer is D. When retrofitting from a fixed orifice metering device such as a piston or capillary tube to a thermostatic expansion valve, TXV, the correct procedure is to remove the old metering device, braze the TXV body into the liquid line at the evaporator inlet, and mount the sensing bulb securely on the suction line at the evaporator outlet. The sensing bulb must contact the suction line surface and be properly insulated to accurately measure suction line temperature for superheat control. Leaving the old device in series would create excessive pressure drop. The sensing bulb must be on the suction line, not the liquid line, because it measures evaporator outlet temperature. Setting superheat to 0 would flood liquid refrigerant back to the compressor, causing slugging and mechanical damage. Question 57. When mounting an evaporator coil in a walk-in cooler, what must be considered to ensure proper condensate drainage? A. The evaporator must be mounted at the lowest point of the cooler near the floor drain. B. The condensate drain pan must connect to a heated drain line outside the cooler space. C. The evaporator must be pitched slightly toward the drain outlet to prevent water pooling. D. The condensate line must be routed upward above the evaporator before exiting the cooler. The correct answer is C. When mounting an evaporator coil in a walk-in cooler, the unit must be pitched slightly toward the drain outlet to ensure proper condensate drainage. During cooling operation and defrost cycles, water collects in the drain pan beneath the evaporator coil. If the evaporator is perfectly level or pitched away from the drain, water will pool in the pan, eventually overflowing onto the floor or refreezing during the next cooling cycle. Accumulated ice in the drain pan reduces airflow through the coil, decreases cooling capacity, and can damage the evaporator over time. The slight pitch, typically about 1 mm per meter, directs water by gravity to the drain connection. While drain line heating is also important for below freezing applications, the question specifically addresses the mounting consideration for the evaporator coil itself. Question 58. What characteristic of our 407C makes it different from our 22 inches terms of charging and leak detection? A. Our 407C has a lower global warming potential than our 22 inches all operating conditions. B. Our 407C is a zeotropic blend with temperature glide that must be charged as a liquid. C. Our 407C operates at significantly lower pressures than our 22 at the same temperatures. D. Our 407C is a single-component refrigerant that can be charged in vapor or liquid phase. The correct answer is B. Our 407C is a zeotropic blend of 3 HFC refrigerants, R32, R125, and R134A. Unlike the single component R22 it replaces, our 407C exhibits temperature glide, meaning the individual components evaporate and condense at different temperatures. This characteristic has two critical implications for installation work. First, our 407C must always be charged in the liquid phase from the cylinder to prevent fractionation, where lighter components would enter the system first and change the blend composition. Second, leak detection and topping off are more complex because any refrigerant that escapes from a leak will have a different composition than the remaining charge, meaning the system cannot simply be topped off like in our 22 system. Significant leaks require recovering the remaining charge, repairing the leak, and recharging with virgin refrigerant. Question 59. When installing concrete anchor bolts to secure a rooftop condensing unit to a concrete curb, what is the correct installation sequence? A. Drill the holes, clean debris with compressed air, insert anchors, and torque to specification. B. Mark hole locations, use a wood drill bit, tap anchors with a rubber mallet only. C. Set anchors before the concrete cures so they bond chemically with the wet mixture. D. Drive anchors into the curb surface without pre-drilling to ensure maximum grip strength. The correct answer is A. The correct installation sequence for concrete anchor bolts is to first drill the holes to the specified diameter and depth using a hammer drill with a masonry bit, then clean all dust and debris from the holes using compressed air or a brush, insert the anchor bolts to the required embedment depth, and finally torque the nuts to the manufacturer specified value. Cleaning the holes is essential because residual concrete dust reduces the holding capacity of the anchors by preventing proper expansion or adhesion against the hole walls. Using the wrong drill bit type, such as a wood bit, will not penetrate concrete effectively and creates oversized holes. Setting anchors in uncured concrete is a technique for cast-in-place anchors, not post-installed mechanical anchors. Driving anchors without pre-drilling would crack the concrete and fail to achieve proper embedment. Question 60. When installing a suction line that rises vertically from a basement evaporator to a rooftop condensing unit, what piping practice ensures proper oil return? A. Installing an oil trap at the base of each vertical riser and sizing the riser for adequate velocity. B. Increasing the suction line diameter at the riser to reduce pressure drop across the rise. C. Sloping the vertical riser backward at a steep angle toward the evaporator outlet connection. D. Adding a secondary oil separator at the midpoint of the riser to collect pooled lubricant. The correct answer is A. When a suction line must rise vertically from a lower evaporator to a higher condensing unit, proper oil return requires two key practices. First, an oil trap, also called a P-trap, must be installed at the base of each vertical riser. This trap collects oil that drains back down the riser during compressor off cycles, and when the compressor restarts, the surge of suction gas carries the accumulated oil up the riser. Second, the vertical riser must be sized to maintain adequate refrigerant gas velocity, typically a minimum of 3.8 to 5.1 meters per second, to carry oil droplets upward against gravity. If the riser is oversized, the gas velocity will be too low to entrain oil, and the oil will drain back to the trap and eventually starve the compressor. For systems with significant capacity variation, double risers may be required to maintain velocity at reduced loads. Question 61. When retrofitting a residential R22 condensing unit with a new R410A unit, why must the existing line set be evaluated? A. R410A operates at lower pressures so the existing copper tubing walls are too thick. B. R410A requires larger diameter tubing than R22 for all line set applications. C. R410A operates at higher pressures so the existing line set must be rated for those pressures. D. R410A uses the same operating pressures as R22 but requires stainless steel tubing. The correct answer is C. R410A operates at significantly higher pressures than R22, with operating pressures approximately 60% higher at the same temperatures. For example, R410A has a saturation pressure of about 2,760 kilopascals at 49 degrees Celsius compared to about 1,790 kilopascals for R22. When retrofitting from an R22 condensing unit to an R410A unit, the existing refrigerant line set must be evaluated to confirm that the copper tubing and all fittings are rated for these higher working pressures. Older line sets installed for R22 systems may use thinner wall tubing or fittings that are not rated for R410A pressures. The line set diameter also needs verification because R410A has different flow characteristics, but the primary safety concern is pressure rating. If the existing line set cannot handle R410A pressures, it must be replaced to prevent a catastrophic rupture during operation. Question 62. What is the purpose of monitoring the nitrogen holding charge pressure over a 24-hour period before proceeding with evacuation? A. To detect slow leaks that would not be found during a short-duration pressure test. B. To verify that the nitrogen has fully dried all moisture from inside the piping walls. C. To confirm the nitrogen pressure has risen, indicating the system is building heat. D. To ensure the nitrogen has converted any residual brazing flux into a harmless compound. The correct answer is A. Monitoring the nitrogen holding charge pressure over an extended period, typically 24 hours, serves as a standing pressure test to detect slow leaks in the newly installed refrigerant piping system. While a short-duration pressure test at higher pressures can identify gross leaks, very small leaks at brazed joints, flare connections, or valve packings may only show a measurable pressure drop over many hours. Temperature changes throughout the day will cause normal pressure fluctuations due to gas expansion and contraction, so the mechanic must account for ambient temperature differences when comparing initial and final readings. A pressure drop that exceeds what can be explained by temperature variation indicates a leak that must be found and repaired before evacuation and charging. Discovering leaks at this stage is far less costly than finding them after the system has been evacuated and charged with refrigerant. Question 63. When placing a thermostat in a conditioned space, what location factor most affects its ability to accurately sense room temperature? A. The distance between the thermostat and the nearest electrical distribution panel. B. The height of the ceiling in the room where the thermostat is being mounted. C. The color of the wall surface directly behind the thermostat mounting plate. D. Exposure to direct sunlight, drafts, or heat sources that create false temperature readings. The correct answer is D. The most critical location factor when placing a thermostat is avoiding exposure to conditions that create false temperature readings. Direct sunlight shining on the thermostat will heat the sensor above actual room temperature, causing the cooling system to run excessively. Heat sources such as lamps, appliances, or hot water pipes in the wall behind the thermostat will similarly create artificially high readings. Drafts from windows, doors, or supply air registers will cause the thermostat to read temperatures that do not represent the average room condition. The thermostat should be mounted on an interior wall, approximately 1.5 meters above the floor, away from windows, doors, supply registers, and heat-producing equipment. Proper placement ensures the thermostat senses a temperature representative of the occupied zone, resulting in accurate control and occupant comfort. Question 64. What is the function of a contactor in a condensing unit control circuit? A. To measure the amperage draw of the compressor motor during startup conditions. B. To convert single-phase power supply into three-phase power for the compressor motor. C. To switch the high-current compressor and fan motor circuits on and off via a low-voltage signal. D. To regulate the speed of the condenser fan motor based on ambient temperature readings. The correct answer is C. A contactor is an electrically operated switch used in condensing unit control circuits to switch high-current loads on and off. In a typical residential or light commercial system, the thermostat sends a low-voltage signal, 24 volts AC, to the contactor coil. When the coil energizes, it pulls in the contactor armature, closing the high-voltage contacts that supply power to the compressor motor and condenser fan motor. When the thermostat is satisfied, the coil de-energizes and a spring returns the contacts to the open position, disconnecting power to the motors. This arrangement allows a small, safe control signal to manage large motor loads without routing high voltage through the thermostat. Contactors are rated by their full load amperage capacity and must be sized to handle the combined current draw of all motors they control. Question 65. When wiring a high-pressure safety switch into a compressor circuit, how must it be connected to ensure proper protection? A. In parallel with the compressor contactor coil so it energizes an alarm relay. B. In series with the compressor contactor coil so opening the switch de-energizes the contactor. C. In series with the condenser fan motor only to shut down airflow on high pressure. D. In parallel with the thermostat circuit so it overrides the cooling demand signal. The correct answer is B. A high-pressure safety switch must be wired in series with the compressor contactor coil in the control circuit. This configuration ensures that when the high-pressure switch opens due to excessive discharge pressure, it breaks the control circuit to the contactor coil, which causes the contactor to de-energize and disconnect power to the compressor. This is a fail-safe arrangement because any interruption in the series circuit, whether from the safety switch, thermostat, or a broken wire, results in the compressor shutting down. If the switch were wired in parallel, the compressor would continue to run even when the high-pressure condition exists, potentially causing compressor damage, relief valve discharge, or catastrophic failure. The high-pressure switch protects against conditions such as condenser airflow blockage, overcharge, non-condensable gases, and condenser fan failure. Question 72. When retrofitting a control system, why would a mechanic replace a standard thermostat with a programmable setback thermostat? A. To increase the maximum cooling capacity of the refrigeration equipment installed. B. To allow the system to operate without any safety controls or pressure switches. C. To eliminate the need for a contactor in the compressor control circuit wiring. D. To reduce energy consumption by automatically adjusting temperature setpoints by schedule. The correct answer is D. A programmable setback thermostat is installed during a control system retrofit to reduce energy consumption by automatically adjusting temperature setpoints according to a pre-programmed schedule. For example, in an air conditioning application, the thermostat can raise the cooling setpoint during unoccupied hours when the building is empty, reducing the runtime of the cooling equipment and lowering electricity costs. During heating season, it can lower the heating setpoint at night. Studies consistently show that setback strategies can reduce HVAC energy consumption by 10 to 30% depending on the building type, occupancy patterns, and climate. The programmable thermostat does not change the system capacity, does not eliminate safety controls, and does not remove the need for a contactor. It simply provides automated scheduling of temperature setpoints that would otherwise require manual adjustment by the building occupant or operator. Question 73. During a pre-startup check of a newly installed split air conditioning system, what must be verified about the compressor oil before energizing the unit? A. The oil was drained completely and replaced with a universal synthetic lubricant blend. B. The oil was mixed with refrigerant to pre-charge the compressor crankcase before startup. C. The oil level is at the manufacturer's specified sight glass mark and the correct oil type was used. D. The oil temperature was raised above ambient by heating the crankcase for at least 1 hour. The correct answer is C. Before initial startup, the compressor oil level must be verified at the manufacturer-specified sight glass mark, and the correct oil type must be confirmed. Different refrigerants require compatible oils. For example, R410A systems use polyester (POE) oil while R22 systems use mineral oil. An incorrect oil type or insufficient level can cause compressor bearing failure, poor lubrication, and premature compressor burnout. The sight glass on the compressor shell provides a visual indication of oil level relative to the manufacturer's minimum and maximum marks. Question 74. What is the primary reason for verifying compressor rotation direction during a pre-startup check on a three-phase system? A. Incorrect rotation prevents the compressor from developing proper discharge pressure. B. Incorrect rotation causes the condenser fan to run at a reduced speed setting. C. Incorrect rotation results in the evaporator fan reversing its airflow direction. D. Incorrect rotation causes the crankcase heater to overheat and trip the breaker. The correct answer is A. On three-phase compressors, reverse rotation prevents the compressor from developing proper discharge pressure because the scroll or screw mechanism compresses refrigerant in one direction only. Running a scroll compressor in reverse produces no pumping action, resulting in no cooling and potential compressor damage from oil starvation and overheating. Rotation is checked by briefly bumping the compressor and observing whether suction and discharge pressures respond correctly, or by using a phase rotation meter before startup to confirm the correct phase sequence. Question 75. Before starting a newly installed refrigeration system, the mechanic checks the electrical connections. What specific wiring verification is essential? A. Confirm that the thermostat wire is shielded to prevent electromagnetic signal interference. B. Verify that all conductors are copper rather than aluminum to meet efficiency requirements. C. Confirm that wire sizes, connections, and voltage match the unit nameplate specifications. D. Verify that the control wiring is routed through the same conduit as the power wiring. The correct answer is C. During pre-startup, the mechanic must confirm that wire sizes match the unit nameplate requirements for minimum circuit ampacity and maximum overcurrent protection. All terminal connections must be tight and properly torqued, and the supply voltage must be within the manufacturer's acceptable range, typically plus or minus 10% of nameplate voltage. Undersized wiring causes voltage drop, overheating, and potential fire hazards. Loose connections create high resistance points that can arc and damage terminals. Verifying these electrical parameters before energizing protects both the equipment and personnel. Question 76. When performing the initial startup of a commercial refrigeration system, what should the mechanic monitor immediately after energizing the compressor? A. The condenser fan blade pitch angle to confirm proper air movement direction. B. The suction and discharge pressures to confirm they respond correctly to compressor operation. C. The color of the refrigerant in the liquid line sight glass over a 5-minute interval. D. The temperature of the evaporator coil surface using an infrared camera for mapping. The correct answer is B. Immediately after compressor startup, the mechanic must monitor suction and discharge pressures to confirm that the compressor is pumping correctly. Suction pressure should drop and discharge pressure should rise upon startup, indicating proper refrigerant flow through the system. Abnormal pressure readings can indicate problems such as reverse rotation on three-phase units, closed service valves, a stuck compressor valve, or a restricted metering device. Early detection of these conditions during initial startup prevents extended operation under fault conditions that could damage the compressor or other system components. Question 77. What does a bubbling or flashing condition in the liquid line sight glass indicate during system startup? A. The system may be undercharged or have a restriction upstream causing a pressure drop. B. The compressor is operating in an overcharged condition with excess liquid refrigerant. C. The condenser fan motor is running at full speed and overcooling the liquid refrigerant. D. The expansion valve is fully closed and blocking refrigerant flow to the evaporator coil. The correct answer is A. Bubbles or flash gas in the liquid-lined sight glass typically indicate that the system is undercharged, meaning there is not enough liquid refrigerant to maintain a solid column of liquid at that point. It can also indicate a restriction upstream of the sight glass, such as a partially blocked filter dryer, that causes enough pressure drop to flash some liquid into vapor. A clear sight glass with no bubbles indicates that liquid refrigerant is properly subcooled at that location. However, a completely empty system or a severely overcharged system can also show a clear sight glass, so pressures and temperatures must be verified alongside the sight glass observation. Question 78. When verifying control system operation during commissioning, what should a mechanic confirm about the high-pressure cutout switch? A. The cutout is set to activate at a pressure 50% above normal discharge pressure. B. The cutout allows the compressor to restart automatically without any manual intervention. C. The cutout bypasses the compressor contactor and signals the building automation system. D. The cutout trips at its set point and shuts down the compressor to prevent unsafe pressure. The correct answer is D. During commissioning, the high-pressure cutout must be verified to trip at its manufacturer-specified setpoint and shut down the compressor to protect against dangerously high discharge pressures. This safety control prevents catastrophic failures such as burst pressure vessels, blown hoses, and compressor damage. The mechanic should simulate or carefully create a high-pressure condition to verify the switch operates at the correct pressure. Many high-pressure cutouts require manual reset to ensure that the cause of the high-pressure condition is investigated before the system is restarted, preventing repeated cycling under a fault condition. Question 79. A mechanic is commissioning a walk-in freezer and needs to verify the defrost control system. What is the correct procedure for confirming defrost termination? A. Run the defrost cycle for a fixed duration of 30 minutes regardless of coil temperature. B. Monitor the discharge pressure to confirm it drops when the defrost heaters are energized. C. Verify the defrost termination thermostat opens the heater circuit when the coil reaches its set point. D. Confirm the evaporator fans remain running at full speed throughout the entire defrost cycle. The correct answer is C. Proper defrost termination relies on the defrost termination thermostat sensing when the evaporator coil has reached a temperature sufficient to melt all ice, typically around 10 degrees Celsius. At this set point the thermostat opens the heater circuit, ending the defrost cycle. The mechanic must verify that the termination thermostat is properly mounted on the evaporator coil, that it opens at the correct temperature, and that the heaters de-energize when it opens. If the termination thermostat fails or is improperly positioned, the defrost cycle either runs too long, wasting energy and raising box temperature, or terminates too early, leaving ice on the coil that progressively reduces airflow and cooling capacity. Question 80. When charging a refrigeration system by the subcooling method, what does the subcooling value represent? A. The temperature difference between the condenser saturation temperature and the liquid line temperature. B. The temperature difference between the suction line and the evaporator saturation temperature. C. The temperature difference between the ambient air and the condenser outlet temperature. D. The temperature at which the refrigerant begins to change from liquid to vapor in the system. The correct answer is A. Subcooling is the difference between the condenser saturation temperature, determined from the discharge pressure and a pressure temperature chart, and the actual liquid line temperature measured at the condenser outlet. For example, if the condenser saturation temperature is 40 degrees Celsius and the liquid line temperature is 32 degrees Celsius, the subcooling is 8 degrees. Subcooling indicates how much the liquid refrigerant has been cooled below its saturation point. A higher subcooling value generally indicates more refrigerant charge in the system. Manufacturers specify a target subcooling value that confirms the correct amount of refrigerant is in the system for optimal performance. Question 81. A mechanic is completing the initial refrigerant charge on a new rooftop air conditioning unit. The manufacturer specifies charging by weight. What is the correct procedure? A. Weigh in the exact factory-specified charge using a refrigerant scale after full evacuation. B. Add refrigerant through the suction service valve until frost appears on the suction line. C. Charge refrigerant until the liquid line sight glass is clear and the system sounds quiet. D. Add refrigerant to the high side only while the compressor is off until pressures equalize. The correct answer is A. When the manufacturer specifies charging by weight, the mechanic must weigh in the exact amount of refrigerant indicated on the unit nameplate or in the installation manual. This is done using a calibrated refrigerant scale after the system has been properly evacuated to remove all non-condensables and moisture. The weighed charge method is highly accurate because it accounts for the exact amount of refrigerant needed for the factory-specified line lengths and conditions. If the line lengths differ from the factory specification, the manufacturer typically provides a per meter adjustment factor to add or subtract from the base charge weight. Question 82. When measuring superheat at the evaporator outlet during charging, the mechanic reads a suction pressure equivalent to -10 degrees Celsius and a suction line temperature of -3 degrees Celsius. What is the superheat? A. -10 degrees Celsius because superheat is measured at the evaporator inlet pressure. B. 7 degrees Celsius because superheat is the suction line temperature minus saturation temperature. C. 3 degrees Celsius because superheat equals the absolute value of the suction line reading. D. 13 degrees Celsius because superheat is the sum of the saturation and suction line values. The correct answer is B. Superheat is calculated by subtracting the evaporator saturation temperature from the actual suction line temperature at the same point. In this example, the saturation temperature corresponding to the suction pressure is -10 degrees Celsius, and the measured suction line temperature is -3 degrees Celsius. Therefore the superheat is -3 minus -10, which equals 7 degrees Celsius. This 7 degrees of superheat confirms that all the liquid refrigerant has evaporated and the vapor has been heated an additional 7 degrees before reaching the measurement point. Superheat within the manufacturer's specified range confirms proper metering device operation and adequate refrigerant charge. Question 83. In a thermostatic expansion valve, what three opposing forces determine the valve opening position during system operation? A. Compressor discharge pressure, condenser fan speed, and ambient air temperature acting on the body. B. Liquid line pressure, oil pressure differential, and crankcase heater temperature on the diaphragm. C. Suction line temperature, discharge line temperature, and subcooling pressure on the valve seat. D. Sensing bulb pressure, evaporator pressure, and superheat spring pressure acting on the diaphragm. The correct answer is D. A thermostatic expansion valve operates based on three forces acting on its diaphragm. The sensing bulb pressure pushes downward to open the valve. It responds to the suction line temperature at the evaporator outlet. The evaporator pressure pushes upward to close the valve, acting on the underside of the diaphragm through the external equalizer connection or internal passage. The superheat spring also pushes upward to close the valve and provides an adjustable offset that sets the minimum superheat. When sensing bulb pressure exceeds the combined closing forces of evaporator pressure and spring pressure, the valve opens further. When the closing forces exceed the bulb pressure, the valve closes. This balance of forces modulates refrigerant flow to maintain the desired superheat at the evaporator outlet, which is essential for both efficient heat transfer and compressor protection. Question 84. When verifying the operating parameters of a newly commissioned walk-in cooler, what should the mechanic compare the measured operating pressures against? A. The pressures recorded on similar units installed in neighboring facilities. B. Industry standard pressure tables that apply universally to all refrigerants. C. The manufacturer's specified operating pressure ranges for the given conditions. D. The previous day's pressure readings from the building automation system log. The correct answer is C. Operating pressures must be compared against the manufacturer's specified ranges for the specific equipment, refrigerant type, and operating conditions. Manufacturers provide design operating data that accounts for the evaporator temperature, condensing temperature, ambient conditions, and load. Generic industry tables do not account for the specific characteristics of each system. The mechanic must verify that suction pressure, discharge pressure, oil pressure differential, and any intermediate pressures all fall within the manufacturer's acceptable ranges. Pressures outside these ranges indicate a problem such as incorrect charge, restricted airflow, a faulty metering device, or a system that has not yet reached steady-state operation. Question 85. A mechanic is verifying the low-pressure cutout setting on a medium-temperature refrigeration system. How should the cutout set point be determined? A. Set it equal to the normal running suction pressure to trigger on any small deviation. B. Set it below the normal operating suction pressure but above the point of coil icing. C. Set it at the lowest possible value the switch allows to avoid nuisance shutdowns. D. Set it at the atmospheric equivalent pressure since the system should never reach vacuum. The correct answer is B. The low-pressure cutout must be set below the normal operating suction pressure to avoid nuisance trips during normal load fluctuations, but above the pressure at which the evaporator coil would begin to accumulate ice or the compressor would operate unsafely. Setting it too close to normal operating pressure causes frequent unnecessary shutdowns, while setting it too low allows the system to operate in harmful conditions such as extremely low suction pressures that cause oil migration, poor lubrication, and motor overheating. The manufacturer's installation manual provides the recommended low-pressure cutout setpoint or a method for calculating it based on the design evaporator temperature. Question 86. What is the purpose of measuring the temperature difference across an evaporator coil during commissioning? A. To calculate the compressor discharge temperature under full load conditions. B. To determine the correct refrigerant type that should be used in the system. C. To measure the refrigerant flow rate passing through the distributor tubes. D. To verify the evaporator is transferring the designed amount of heat from the air. The correct answer is D. Measuring the temperature difference between the air entering and leaving the evaporator coil, known as the delta T, verifies that the evaporator is transferring the designed amount of heat. For most air conditioning systems, this difference is typically in the range of 8 to 12 degrees Celsius. A low delta T may indicate insufficient refrigerant charge, a dirty coil, excessive airflow, or a faulty metering device. A high delta T may indicate restricted airflow from a dirty filter, a failed blower motor, or collapsed ductwork. This measurement is a fundamental commissioning check that confirms the system is performing as designed. Question 87. During system integration verification, a mechanic needs to confirm that the condenser fan cycles correctly with the head pressure control. What should be observed? A. The condenser fan should run continuously at maximum speed regardless of ambient temperature. B. The condenser fan should turn on only when the compressor is off to reduce power consumption. C. The condenser fan should reverse direction periodically to clean debris from the condenser coil. D. The condenser fan should cycle on and off to maintain discharge pressure within the designed range. The correct answer is D. Head pressure controls cycle condenser fans on and off, or modulate fan speed, to maintain the discharge pressure within a designed operating range. During cold ambient conditions, if all condenser fans ran continuously, the condensing pressure could drop too low for the expansion device to operate properly, resulting in poor refrigerant flow and inadequate cooling. The mechanic verifies that as discharge pressure drops, condenser fans stage off or slow down, and as pressure rises, fans stage on or speed up. This integration between the pressure control and the fan staging must be confirmed during commissioning to ensure stable system operation across all expected ambient temperature conditions. Question 88. When verifying the integration of a building automation system with a chiller during commissioning, what communication check should the mechanic perform? A. Confirm that the automation system can read chiller status points and send control commands. B. Verify that the automation system can display the chiller nameplate data continuously. C. Confirm that the automation system receives weather data from the internet in real time. D. Verify that the automation system can read the installation manual stored in its memory. The correct answer is A. During integration verification, the mechanic must confirm that the building automation system can successfully read operational status points from the chiller, such as entering and leaving water temperatures, refrigerant pressures, compressor status, and alarm conditions. The system must also be able to send control commands to the chiller, such as enable and disable, chilled water setpoint adjustments, and demand limiting signals. This two-way communication is verified by observing the automation system interface while the chiller is operating and confirming that displayed values match local gauge readings. The mechanic also tests that commands sent from the automation system produce the expected response at the chiller. Question 89. What is the primary goal of system optimization during the commissioning process for an HVAC/R system? A. To increase the refrigerant charge beyond the factory specification for extra capacity reserve. B. To disable safety controls temporarily so the system can reach its peak cooling output. C. To replace the standard metering device with an oversized version for faster pull-down times. D. To adjust operating parameters so the system achieves maximum efficiency at design conditions. The correct answer is D. System optimization during commissioning focuses on fine-tuning operating parameters so the system achieves the highest possible efficiency while meeting the design cooling or heating load. This includes adjusting superheat and subcooling to manufacturer specifications, verifying airflow rates across coils, setting fan speeds appropriately, calibrating controls for accurate temperature regulation, and confirming that staging sequences operate efficiently. A properly optimized system uses less energy, provides more consistent temperatures, reduces equipment wear, and extends component life. Optimization must be performed under conditions as close to design load as possible for accurate results. Question 90. A mechanic is optimizing a multi-zone rooftop unit and discovers that one zone is consistently overcooled while another is undercooled. What is the most appropriate corrective action? A. Increase the total system refrigerant charge to provide more capacity to the weak zone. B. Lower the thermostat setpoint in the overcooled zone to compensate for the temperature offset. C. Adjust the zone dampers or airflow balancing devices to redistribute air to each zone. D. Replace the single compressor with a larger model to provide more total cooling capacity. The correct answer is C. When one zone is overcooled and another is undercooled in a multi-zone system, the problem is typically unbalanced airflow distribution rather than insufficient total capacity. The mechanic should adjust zone dampers, balancing dampers, or variable air volume terminal units to redirect more air to the undercooled zone and reduce air to the overcooled zone. This rebalancing distributes the available cooling capacity proportionally to each zone's load requirement. Adding refrigerant or increasing compressor size would not solve the distribution problem and could create other issues such as overcharging or short cycling. Proper airflow balancing is a fundamental commissioning step that ensures comfort in all zones. Question 91. During commissioning of a supermarket refrigeration rack system, the suction pressure is within specification but several display cases have product temperatures above the acceptable range. What should the mechanic investigate first? A. The compressor oil level in the rack system oil reservoir and oil return piping arrangement. B. The condenser water treatment program and cooling tower fan belt tension for proper operation. C. The discharge pressure setpoint and head pressure control staging for the entire rack system. D. The individual case evaporator airflow and expansion valve operation for the affected cases. The correct answer is D. When the rack suction pressure is within specification, the compressors are maintaining the proper system-wide suction condition, so the problem is localized to the individual display cases rather than the central rack. The mechanic should investigate the evaporator airflow and expansion valve operation in each affected case. Possible causes include dirty evaporator coils restricting airflow, failed evaporator fan motors, improperly adjusted or failed thermostatic expansion valves, plugged distributor tubes, or ice accumulation from inadequate defrost. Each case is essentially an individual evaporator circuit, and problems in one case do not necessarily affect others. By focusing on the case-level components first, the mechanic can identify and correct the specific cause without making unnecessary changes to the central rack system. Question 92. What information must be recorded in the commissioning documentation for a newly installed refrigeration system? A. Only the date of installation and the name of the installing contractor for warranty purposes. B. Operating pressures, temperatures, refrigerant charge, electrical readings, and control set points. C. Only the refrigerant type and total charge weight for environmental tracking requirements. D. Only the electrical measurements at the main disconnect for the building electrical records. The correct answer is B. Complete commissioning documentation must record all critical operating parameters including suction and discharge pressures, superheat and subcooling values, operating temperatures throughout the system, total refrigerant charge weight and type, voltage and amperage readings on all motors, and all control setpoints such as thermostat, high pressure cutout, low pressure cutout, oil pressure differential, and defrost settings. This baseline data serves as a reference for future service and troubleshooting. When a system develops problems later, comparing current readings to the commissioning data helps identify what has changed. Commissioning documentation is also required for warranty validation, regulatory compliance, and owner turnover. Question 93. After completing commissioning of a commercial refrigeration system, what documentation must the mechanic provide to the system owner as part of the turnover package? A. Only the original purchase invoice and a signed statement that the system was turned on. B. A copy of the mechanic's trade certification and proof of insurance for liability purposes. C. Equipment manuals, warranty information, maintenance schedules, and the completed commissioning report. D. The supplier's wholesale price list and a breakdown of the markup on all installed components. The correct answer is C. The turnover package provided to the system owner must include all equipment operation and maintenance manuals, warranty registration documents, recommended maintenance schedules from the manufacturer, and the completed commissioning report with all baseline operating data. This documentation enables the owner and future service technicians to properly operate and maintain the system. The commissioning report provides the critical baseline reference data for all operating parameters. Maintenance schedules inform the owner of required service intervals for filters, coils, belts, and other components. Without this documentation, the owner lacks the information needed to maintain the system and validate warranty claims. Question 94. During a routine inspection of a commercial walk-in cooler, what should a technician check first when assessing evaporator performance? A. The voltage reading at the compressor terminal block inside the condensing unit. B. The superheat setting stamped on the thermostatic expansion valve body label. C. The refrigerant charge level by weighing the total amount of refrigerant in system. D. The temperature difference between entering and leaving air across the evaporator coil. The correct answer is D. Checking the temperature difference, TD, across the evaporator coil is the primary indicator of evaporator performance during a routine inspection. The TD between entering and leaving air reveals whether the coil is transferring heat effectively. An abnormally high TD can indicate low airflow from a dirty coil or failed fan motor, while an abnormally low TD may suggest insufficient refrigerant flow or a frosted coil. This measurement is non-invasive and quickly identifies whether further diagnostic steps are needed, making it the logical first check in any evaporator performance assessment. Question 95. What is the primary purpose of inspecting condenser coils during scheduled HVAC/R maintenance? A. To verify the refrigerant charge weight matches the nameplate specification. B. To ensure adequate heat rejection by confirming coils are clean and unobstructed. C. To measure the electrical resistance of the condenser fan motor windings. D. To confirm that the liquid line filter dryer is not saturated with moisture. The correct answer is B. Condenser coil inspection ensures adequate heat rejection, which is critical to system efficiency and longevity. Dirty or obstructed condenser coils restrict airflow, causing elevated condensing pressures and temperatures. This forces the compressor to work harder, increasing energy consumption and accelerating wear on components. Over time, high head pressure from a dirty condenser can lead to compressor failure. Regular visual inspection and cleaning of condenser coils is one of the most impactful preventive maintenance tasks a technician can perform. Question 96. When performing scheduled maintenance on a belt-driven condenser fan, what measurement determines whether the V-belt requires replacement? A. The ambient temperature surrounding the condensing unit during operation. B. The amperage draw of the condenser fan motor at full load conditions. C. The belt deflection when moderate thumb pressure is applied at mid-span. D. The condensing pressure reading taken from the high side service valve. The correct answer is C. Belt deflection measured at mid-span is the standard method for determining V-belt condition and tension. When moderate thumb pressure is applied at the midpoint between pulleys, the belt should deflect approximately 12 to 19 mm per 300 mm of span for a properly tensioned belt. Excessive deflection indicates a stretched or worn belt that requires adjustment or replacement. A loose belt slips on the pulleys, reducing fan speed and airflow across the condenser, which directly impacts system capacity and efficiency. Cracking, glazing, or fraying visible during this check also warrants immediate replacement. Question 97. What is the correct procedure when performing an oil analysis on a semi-hermetic compressor during predictive maintenance? A. Drain the entire oil charge and replace it with new oil before sampling. B. Collect the sample while the compressor is operating at maximum capacity. C. Draw the sample from the suction line accumulator drain port exclusively. D. Take the sample from the compressor oil drain or sight glass port into a clean container. The correct answer is D. Oil analysis samples must be taken from the compressor crankcase via the oil drain valve or sight glass port into a clean, sealed container to ensure the sample accurately represents the oil circulating through the compressor. The compressor should be at normal operating temperature so contaminants are suspended in the oil rather than settled. The sample is then sent to a laboratory for analysis of acid number, moisture content, metal particulates, and viscosity. This predictive maintenance technique identifies internal compressor wear, refrigerant contamination, and oil degradation before catastrophic failure occurs. Question 98. What condition does elevated vibration amplitude at bearing frequencies indicate during predictive maintenance on a compressor? A. Bearing wear or deterioration requiring further inspection or replacement. B. Excessive refrigerant charge causing liquid slugging in the compressor. C. A clogged suction line filter dryer restricting refrigerant flow to the unit. D. An improperly adjusted crankcase heater failing to boil off liquid refrigerant. The correct answer is A. Vibration analysis is a key predictive maintenance tool for rotating equipment. Elevated vibration amplitude at bearing-specific frequencies, such as the ball pass frequency of the outer race or inner race, directly indicates bearing wear or deterioration. As bearing surfaces degrade, increased clearances and surface defects generate characteristic vibration signatures that can be detected with accelerometers and spectrum analyzers. Identifying bearing wear early through vibration monitoring allows planned replacement during scheduled downtime, preventing unexpected compressor failure, secondary damage to other internal components, and costly emergency service calls. Question 99. When testing a thermostatic expansion valve on a refrigeration system, what operating parameter confirms the valve is metering correctly? A. The discharge pressure measured at the compressor high side service port. B. The superheat measured at the evaporator outlet compared to the design setpoint. C. The oil level visible in the compressor crankcase sight glass during operation. D. The amperage draw of the compressor motor measured with a clamp-on ammeter. The correct answer is B. Superheat measured at the evaporator outlet is the primary indicator of thermostatic expansion valve performance. The TXV modulates refrigerant flow to maintain a specific superheat, typically 5 to 7 degrees Celsius for most commercial applications. Superheat is calculated by subtracting the saturated suction temperature from the actual suction line temperature at the evaporator outlet. If superheat is too high, the valve is underfeeding the evaporator, reducing capacity. If superheat is too low or non-existent, the valve is overfeeding, risking liquid flood back to the compressor. Comparing the measured superheat to the design setpoint confirms proper TXV operation. Question 100. A technician is testing the capacity of a water-cooled condenser on a chiller. What measurement pair is needed to calculate condenser heat rejection? A. Ambient air temperature and compressor discharge pressure at full load. B. Refrigerant charge weight and compressor oil level in the crankcase. C. Suction line temperature and liquid line temperature at the condenser outlet. D. Water flow rate through the condenser and the entering to leaving water temperature rise. The correct answer is D. Condenser heat rejection is calculated using the water side measurements, flow rate multiplied by the temperature differential between entering and leaving water, multiplied by the specific heat of water. The formula is Q equals m dot times Cp times delta T. If the water flow rate is measured in liters per second and the temperature rise in degrees Celsius, the result in kilowatts represents the total heat rejected by the condenser. This includes both the heat absorbed from the conditioned space plus the heat of compression. Comparing the calculated heat rejection to the design rating reveals whether the condenser is performing at rated capacity or has fouled tubes, reducing heat transfer efficiency. Question 101. What is the primary goal of optimizing integrated system performance during HVAC/R maintenance? A. To achieve design conditions while minimizing energy consumption. B. To increase the refrigerant charge beyond the nameplate specification. C. To bypass safety controls to achieve lower operating temperatures. D. To reduce the number of scheduled maintenance visits per year. The correct answer is A. The primary goal of optimizing integrated system performance is to ensure the HVAC/R system operates at its design conditions, maintaining required temperatures and humidity levels, while consuming the least amount of energy possible. Optimization involves verifying that all components work together efficiently, including proper superheat and subcooling, correct airflow and water flow rates, appropriate operating pressures, and properly functioning controls. When the entire system is optimized as an integrated unit rather than individual components, energy waste is minimized and equipment life is extended. Question 102. When optimizing the performance of a multi-evaporator refrigeration system, what adjustment corrects uneven case temperatures between display cases? A. Increasing the condensing unit fan speed to lower the discharge pressure. B. Adjusting individual evaporator pressure regulators to balance suction pressures. C. Replacing the liquid line filter dryer with a larger capacity unit. D. Reducing the compressor unloading stages to maintain constant capacity. The correct answer is B. In multi-evaporator systems, evaporator pressure regulators installed at the outlet of each evaporator control the minimum evaporating pressure and therefore the temperature in each individual case. When display cases show uneven temperatures, adjusting these regulators balances the suction pressure from each evaporator to achieve the correct operating temperature for each case. Cases requiring warmer temperatures have their regulators set to maintain higher evaporating pressures, while cases requiring colder temperatures operate at lower pressures. This targeted adjustment ensures each case reaches its design temperature without affecting others in the system. Question 103. During inspection of a rooftop air conditioning unit, what condition found on the evaporator coil indicates a potential airflow restriction? A. A thin layer of condensation forming evenly across the entire coil surface. B. Ice formation beginning at the bottom of the coil and progressing upward. C. Slight vibration of the coil when the supply fan is operating at full speed. D. A uniform temperature reading across the face of the coil at every location. The correct answer is B. Ice formation beginning at the bottom of the evaporator coil and progressing upward is a classic indicator of restricted airflow. When airflow across the coil is insufficient due to dirty filters, a blocked return air grill, or a failing blower motor, the coil surface temperature drops below the dew point and then below freezing. Ice forms first where the refrigerant enters the coil at its coldest point, typically at the bottom, and gradually builds upward as the restriction worsens. This ice further blocks airflow, creating a cascading failure that can eventually freeze the entire coil and risk liquid flood back to the compressor. Question 104. What is the most common cause of abnormally high head pressure in an air-cooled refrigeration system? A. A thermostat calling for cooling when the space is already at temperature. B. An oversized liquid line filter dryer creating minimal pressure drop. C. An evaporator fan motor running at a higher speed than the design rating. D. A dirty condenser coil restricting airflow and reducing heat rejection. The correct answer is D. A dirty condenser coil is the most common cause of abnormally high head pressure in air-cooled systems. When dirt, debris, cottonwood seeds, or other contaminants accumulate on the condenser coil fins, airflow through the coil is restricted. Reduced airflow diminishes the condenser's ability to reject heat from the refrigerant to the ambient air. The refrigerant must condense at a higher temperature and pressure to transfer the required heat through the reduced surface area. Other causes of high head pressure include condenser fan failure, non-condensable gases in the system, and refrigerant overcharge, but dirty coils remain the most frequently encountered cause in field service. Question 105. A technician finds that a walk-in freezer compressor is short-cycling on the high-pressure cutout. The condenser coil is clean and the condenser fan is operating. What should be checked next? A. The evaporator defrost timer to verify the defrost cycle duration setting. B. The superheat at the evaporator outlet to confirm TXV operation range. C. The system refrigerant charge for possible overcharge by checking subcooling. D. The compressor crankcase heater to verify oil temperature is adequate. The correct answer is C. When a compressor short cycles on the high-pressure cutout and the condenser coil is clean with the fan operating, the next logical check is the refrigerant charge level. An overcharged system floods the lower portion of the condenser with excess liquid refrigerant, reducing the effective condensing surface area and causing head pressure to rise above the cutout setting. Checking subcooling at the condenser outlet provides an accurate indication of charge level. Abnormally high subcooling combined with high head pressure strongly suggests overcharge. Non-condensable gases such as air should also be considered, but overcharge is more likely if the system was recently serviced. Question 106. When troubleshooting a system with low suction pressure and low superheat, what is the most likely cause? A. A restricted metering device limiting refrigerant flow to the evaporator. B. A compressor with worn valve plates causing excessive internal bypass. C. An overcharged system with liquid refrigerant flooding the evaporator coil. D. A condenser fan running in reverse causing high discharge temperatures. The correct answer is A. Low suction pressure combined with low superheat indicates that the evaporator is being starved of refrigerant. A restricted metering device, whether a partially blocked thermostatic expansion valve, a clogged orifice, or a restricted capillary tube, limits the mass flow of refrigerant entering the evaporator. The small amount of refrigerant that does pass through evaporates quickly near the inlet, producing low superheat at the outlet while the majority of the coil remains inactive. This reduces the evaporating pressure because less refrigerant is boiling in the coil. The result is poor cooling capacity and potential compressor overheating due to high suction gas temperature further into the suction line. Question 107. What symptom indicates the presence of non-condensable gases such as air in a refrigeration system? A. Suction pressure that is consistently lower than the design evaporating pressure. B. Evaporator coil that ices up uniformly from the inlet to the outlet of the coil. C. Compressor oil that appears dark and contains metallic particles when sampled. D. Head pressure that is higher than expected based on ambient temperature conditions. The correct answer is D. Non-condensable gases, most commonly air that entered the system during service or through a leak on the low side operating below atmospheric pressure, collect in the condenser. Because these gases do not condense into liquid at system operating pressures, they occupy space in the condenser that would otherwise be used for refrigerant condensation. This reduces the effective condensing surface area and raises the head pressure above what is expected based on the ambient temperature. The elevated head pressure increases compressor energy consumption and reduces system capacity. Purging non-condensables from the top of the condenser or receiver while the system is off restores normal operation. Question 108. A single-phase compressor hums but does not start, and the thermal overload trips after several seconds. The power supply voltage is correct. What component should be tested first? A. The thermostat to verify that it is calling for cooling at the correct set point. B. The condenser fan motor to confirm it is running and providing adequate airflow. C. The start capacitor or start relay to determine if the start winding is being energized. D. The liquid line solenoid valve to confirm refrigerant is flowing to the metering device. The correct answer is C. When a single-phase compressor hums but fails to start with correct supply voltage, the start circuit is the most likely cause. The hum indicates the run winding is energized and the motor is attempting to start, but the rotor cannot accelerate to operating speed. A failed start capacitor cannot provide the phase shift needed to energize the start winding and create the rotating magnetic field required for motor starting. Similarly, a defective start relay may fail to connect the start winding circuit. Without the start winding contribution, the motor stalls and draws locked rotor amperage, quickly tripping the thermal overload. Testing the start capacitor with a capacitance meter and checking the start relay for continuity identifies the failed component. Question 109. When troubleshooting a heat pump that provides cooling but fails to heat, what component is the most likely cause of the malfunction? A. The compressor contactor because it cannot energize the compressor windings. B. The indoor blower motor because it is not moving air across the evaporator. C. The liquid line filter dryer because it is blocking refrigerant flow in both modes. D. The reversing valve because it is not switching the refrigerant flow direction. The correct answer is D. A heat pump that operates normally in cooling mode but fails in heating mode points directly to the reversing valve as the most likely cause. The reversing valve, also called a four-way valve, redirects refrigerant flow between heating and cooling modes by switching which coil serves as the condenser and which serves as the evaporator. If the valve fails to shift position due to a stuck slide, a failed solenoid coil, or a broken pilot valve, the system remains in cooling mode regardless of the thermostat call. Components such as the compressor, blower motor, and filter dryer function in both modes, so their failure would affect cooling and heating equally. Question 110. What condition causes liquid flood back to the compressor during system operation? A. Excessive refrigerant entering the evaporator that does not fully vaporize before reaching the suction line. B. A condenser fan cycling off at low ambient temperatures to maintain minimum head pressure. C. An accumulator installed in the suction line that collects liquid before it reaches the compressor. D. A crankcase heater energized during the off cycle to maintain compressor oil temperature. The correct answer is A. Liquid floodback occurs when more refrigerant enters the evaporator than can be vaporized by the available heat load. The unevaporated liquid refrigerant travels through the suction line and enters the compressor in liquid form. This can be caused by an overfeeding metering device, an oversized evaporator relative to the load, a sudden decrease in heat load, or a failed TXV that is stuck open. Liquid refrigerant entering the compressor is incompressible and can cause severe mechanical damage including broken valve plates, damaged reed valves, scored cylinder walls, and bearing washout from diluted oil. Superheat monitoring at the evaporator outlet is the primary protection against this condition. Question 111. What is the correct sequence when replacing a burned-out compressor in a hermetic refrigeration system? A. Install the new compressor, then evacuate, then recover refrigerant from the old system. B. Remove the old compressor, charge with nitrogen, then braze in the replacement unit. C. Pressurize the system with refrigerant, remove the old compressor, then install the new unit. D. Recover the refrigerant, install a suction line filter dryer, then install the replacement compressor. The correct answer is D. When replacing a burned-out hermetic compressor, the refrigerant must first be recovered from the system into an approved recovery cylinder. This is required both by environmental regulations and to allow safe opening of the system. After recovery, the old compressor is removed and a suction line filter dryer, often a burnout-rated activated alumina core type, is installed to capture acid and contaminant residue from the motor burnout. The new compressor is then brazed into place using nitrogen flow to prevent internal oxidation. After installation, the system is evacuated to remove moisture and non-condensables, leak tested, and then recharged with the correct refrigerant type and quantity. Question 112. A technician replaces a TXV on a medium-temperature refrigeration case. After evacuation and recharging, the case temperature is satisfactory but the compressor amperage is elevated and the suction line is sweating back to the compressor. What is the most likely cause? A. The replacement TXV has a capacity rating that is too small for the evaporator coil. B. The new TXV sensing bulb is mounted on the wrong side of the suction line elbow. C. The replacement TXV has a capacity rating that is too large and is overfeeding the evaporator. D. The evacuation process left excessive moisture that is freezing inside the metering orifice. The correct answer is C. A sweating suction line extending back to the compressor combined with elevated compressor amperage indicates liquid flood back from an overfeeding TXV. When a replacement TXV has a capacity rating larger than the evaporator requires, it meters too much refrigerant into the coil. The excess liquid cannot fully evaporate within the evaporator and travels down the suction line toward the compressor. The sweating occurs because the liquid-laden suction line is much colder than the surrounding air. Elevated amperage results from the compressor attempting to handle the liquid refrigerant, which increases the compression work. While the case temperature may appear acceptable initially, this condition causes compressor damage over time and must be corrected by installing a properly sized valve. Question 113. What is the purpose of installing a suction line accumulator in a refrigeration or heat pump system? A. To increase the refrigerant charge capacity of the system beyond design limits. B. To filter particulate contaminants from the suction gas before it reaches the compressor. C. To prevent liquid refrigerant from reaching the compressor by storing excess liquid. D. To reduce noise and vibration transmitted through the suction piping to the building. The correct answer is C. A suction line accumulator is a protective device installed in the suction line directly before the compressor. Its primary purpose is to prevent liquid refrigerant from entering the compressor by acting as a temporary storage vessel. During conditions that may cause liquid floodback, such as defrost cycles, sudden load changes, or heat pump reversing valve transitions, liquid refrigerant collects in the bottom of the accumulator. A metering orifice in the U-tube inside the accumulator allows small amounts of liquid to be drawn into the suction gas stream gradually, where it can evaporate safely before entering the compressor. This protects the compressor from the mechanical damage that liquid slugging would cause. Question 114. When replacing a contactor on a commercial condensing unit, what must be verified before energizing the new contactor? A. The condenser coil has been recently cleaned and is free of debris accumulation. B. The contact rating matches or exceeds the compressor full load amperage requirement. C. The refrigerant charge has been recovered and weighed into a recovery cylinder. D. The thermostat setpoint has been lowered below the current space temperature. The correct answer is B. Before energizing a new contactor, the technician must verify that the contact rating of the replacement contactor matches or exceeds the full load amperage of the compressor and any other loads it controls. An undersized contactor will overheat at the contact points, causing pitting, welding, and eventual failure that can also damage the compressor. The coil voltage of the new contactor must also match the control circuit voltage. Verifying proper wire gauge connections and tightening all terminal screws prevents high-resistance connections. These electrical verifications are essential safety and reliability checks that prevent premature component failure and potential fire hazards. Question 115. What is the correct method for locating a refrigerant leak in a system that has lost most of its charge? A. Operate the system at full capacity and check all fittings with a halide torch. B. Add refrigerant to the system until pressures stabilize, then listen for hissing sounds. C. Pressurize the system with dry nitrogen and apply leak detection solution to joints. D. Evacuate the system to a deep vacuum and monitor the vacuum gauge for pressure rise. The correct answer is C. When a system has lost most of its charge, the correct leak detection method is to pressurize it with dry nitrogen to the manufacturer's recommended test pressure and systematically apply leak detection solution to all joints, fittings, and connections. Nitrogen is used because it is dry, non-toxic, inexpensive, and available at pressures sufficient for testing. The soap-like leak detection solution produces visible bubbles at the point of any leak. This method is preferred over electronic leak detectors when the system has little or no refrigerant remaining, as electronic detectors require refrigerant present to function. A trace amount of refrigerant can be added to the nitrogen to enable electronic detection for very small leaks. Question 116. What is the function of a run capacitor in a single-phase compressor motor circuit? A. To improve the power factor and running efficiency by maintaining a phase shift in the motor. B. To provide a high voltage pulse to overcome the compressor locked rotor condition. C. To store energy for the start winding and disconnect it once the motor reaches speed. D. To regulate the supply voltage to protect the compressor from power surges. The correct answer is A. A run capacitor remains in the circuit during continuous motor operation, unlike a start capacitor which is disconnected after startup. The run capacitor maintains a phase shift between the start and run windings of the single-phase motor, which improves the motor's power factor and running efficiency. Without the run capacitor, the motor operates with a less efficient rotating magnetic field, drawing higher current and producing less torque. A failed run capacitor causes the motor to draw excessive amperage, overheat, and potentially trip the overload. Run capacitors are oil-filled and rated for continuous duty, distinguishing them from electrolytic start capacitors which are designed only for brief high-current starting. Question 117. After replacing a condenser fan motor on a rooftop unit, the technician notices the head pressure is higher than before the repair despite the motor running. What should be checked? A. The fan blade rotation direction to confirm airflow is moving through the condenser coil correctly. B. The thermostat anticipator setting to verify it matches the new motor current draw. C. The evaporator coil to confirm it has not iced up during the repair downtime period. D. The refrigerant charge to determine if some was lost during the motor replacement work. The correct answer is A. When a replacement condenser fan motor is running but head pressure remains elevated, the most likely cause is incorrect fan blade rotation direction. If the motor leads are connected to the wrong supply wires, the motor rotates in the opposite direction, pushing air away from the condenser coil instead of pulling it through. While the motor appears to operate normally at first glance, the reversed airflow drastically reduces heat rejection capacity. On three-phase motors, swapping any two of the three power leads corrects the rotation. On single-phase motors, the wiring diagram on the motor nameplate indicates the correct lead configuration for the desired rotation direction. Verifying airflow direction immediately after motor replacement prevents prolonged high-pressure operation. Question 118. A building management system shows a chilled water supply temperature that is 3 degrees higher than the local gauge on the chiller. The sensor was recently replaced. What is the most likely cause of the discrepancy? A. The chilled water pump is cavitating and creating turbulence at the sensor location. B. The replacement temperature sensor has an incorrect resistance curve for the BMS input. C. The chiller is operating at reduced capacity because of a refrigerant undercharge. D. The building management system software requires a full restart after any sensor change. The correct answer is B. When a recently replaced temperature sensor reads differently from a local gauge, the most likely cause is a sensor-to-input mismatch. Temperature sensors used in building management systems have specific resistance curves, such as 10 Kelvin Type 2, 10 Kelvin Type 3, 1 Kelvin Platinum RTD, or other standards. If the replacement sensor has a different resistance temperature characteristic than what the BMS input is configured to read, the displayed temperature will be offset from the actual value. For example, installing a 10 Kelvin Type 3 sensor on an input calibrated for 10 Kelvin Type 2 produces a consistent offset across the operating range. The correct resolution is to verify the sensor type matches the BMS configuration or reconfigure the input to match the installed sensor. Question 119. What is the purpose of regularly inspecting electrical connections in HVAC/or control panels? A. To identify loose or corroded connections that could cause control malfunctions. B. To verify that the control panel paint finish is intact and free of corrosion. C. To confirm that the control panel door gasket maintains an airtight seal. D. To check that the panel nameplate data matches the original installation drawings. The correct answer is A. Regular inspection of electrical connections in HVAC/or control panels identifies loose, corroded, or overheated connections before they cause system malfunctions or safety hazards. Thermal cycling, vibration from compressors and fans, and environmental exposure cause terminal screws to loosen over time. A loose connection creates high electrical resistance at the contact point, generating heat that can damage wire insulation, melt terminal blocks, or cause intermittent control signals. Corroded connections from moisture infiltration similarly increase resistance. During inspection, the technician checks for discoloration of wires and terminals indicating overheating, verifies terminal tightness with appropriate torque, and ensures wire insulation is not cracked or brittle. Question 120. When calibrating a pressure transducer on a refrigeration system, what reference instrument provides the known accurate pressure for comparison? A. A certified test gauge or digital manometer with traceable calibration accuracy. B. The compressor nameplate maximum operating pressure rating for the system. C. The temperature pressure chart value for the refrigerant at ambient temperature. D. The building management system pressure reading displayed on the operator screen. The correct answer is A. Calibrating a pressure transducer requires comparing its output to a known accurate reference. A certified test gauge or digital manometer with traceable calibration to a recognized standard provides this reference. Traceability means the instrument has been calibrated against standards that can be traced back to national measurement standards through an unbroken chain of comparisons. During calibration, the test gauge and the transducer being calibrated are connected to the same pressure source. Readings are compared at several points across the operating range, and the transducer zero and span are adjusted until its output matches the reference with an acceptable tolerance, typically within 1% of the full-scale range. Question 121. When adjusting an electromechanical defrost timer on a commercial freezer, what parameter must be set to prevent excessive frost buildup on the evaporator? A. The compressor discharge pressure limit at which defrost terminates automatically. B. The defrost interval and duration to match the frost accumulation rate of the application. C. The condenser fan delay timer that controls post-defrost fan operation timing. D. The liquid line solenoid valve closing delay to prevent refrigerant migration. The correct answer is B. The two critical parameters on an electromechanical defrost timer are the defrost interval, which determines how often defrost cycles occur, and the defrost duration, which controls how long each defrost cycle lasts. These must be matched to the specific application's frost accumulation rate. A walk-in freezer with frequent door openings introduces more moisture and requires more frequent defrost cycles than a sealed low-temperature cabinet. If the interval is too long, excessive frost builds up on the evaporator coil, blocking airflow and reducing cooling capacity. If the duration is too short, the defrost cycle terminates before all frost is removed. Conversely, excessive frequency or duration wastes energy and raises box temperature unnecessarily. Question 122. What does a continuously energized liquid line solenoid valve on a pump-down system indicate when the thermostat is satisfied? A. A properly functioning system that is maintaining the correct box temperature. B. A refrigerant undercharge that prevents the low-pressure cutout from being reached. C. A condenser fan motor failure causing the system to operate at elevated pressures. D. A faulty thermostat or control relay that is not opening the solenoid valve circuit. The correct answer is D. In a pump-down control system, the thermostat controls the liquid line solenoid valve rather than the compressor directly. When the thermostat is satisfied and the space has reached the desired temperature, it should de-energize the liquid line solenoid valve, closing it and stopping refrigerant flow to the evaporator. The compressor then continues to run until suction pressure drops to the low-pressure cutout setting, at which point it shuts off. If the solenoid valve remains energized when the thermostat should be satisfied, the control circuit has a fault. This could be a stuck thermostat contact, a failed control relay, or a wiring issue that keeps the solenoid coil powered. The compressor will run continuously because refrigerant keeps flowing to the evaporator. Question 123. A variable frequency drive controlling a chilled water pump displays an overcurrent fault after a power restoration. The pump rotates freely by hand and the motor windings test normal. What should the technician investigate? A. The VFD acceleration ramp time setting to determine if it is too aggressive for the load. B. The chilled water supply temperature to determine if the chiller is operating properly. C. The building management system schedule to confirm the pump should be running now. D. The expansion tank air charge to verify correct system pressurization is maintained. The correct answer is A. When a VFD trips on overcurrent after power restoration despite a free spinning pump and healthy motor windings, the acceleration ramp time is the primary suspect. VFDs can lose their programmed parameters during power interruptions if they lack non-volatile memory backup or if the backup has failed. A factory default acceleration ramp, often as short as 2 to 5 seconds, may be too aggressive for a chilled water pump connected to a large piping system. The inertia of the water in the piping requires a longer ramp-up time to avoid excessive starting current. Reprogramming the ramp time to 30 seconds or longer, depending on system size, typically resolves the overcurrent fault. Verifying all VFD parameters against the commissioning record after a power event is a recommended practice. Question 124. When replacing a temperature sensor in a walk-in cooler that is connected to a building management system, what must be done after physical installation? A. The walk-in cooler door gaskets must be inspected to prevent warm air infiltration. B. The sensor calibration offset must be verified in the BMS to ensure accurate readings. C. The evaporator fan motors must be tested to verify correct rotation direction. D. The condensing unit must be shut down and restarted to register the new component. The correct answer is B. After physically installing a replacement temperature sensor, the technician must verify the sensor calibration offset in the building management system to ensure accurate temperature readings. Even sensors of the correct type can have slight manufacturing tolerances that create small offsets from the true temperature. The BMS input may also have a calibration offset from the previous sensor that needs to be cleared or adjusted for the new sensor. The technician should compare the BMS reading to a known accurate reference thermometer placed near the sensor and adjust the BMS calibration offset until the readings agree with an acceptable tolerance. Without this verification step, the BMS may control the cooler to an incorrect temperature setpoint, potentially compromising food safety or wasting energy. Question 125. What is the primary reason for replacing a corroded wire terminal in an HVAC/air control circuit rather than simply tightening it? A. A tightened corroded terminal maintains high resistance that generates heat and fails again. B. A tightened corroded terminal changes the control voltage to an incorrect level. C. A tightened corroded terminal will cause the circuit breaker to trip immediately. D. A tightened corroded terminal alters the refrigerant flow rate through the system. The correct answer is A. Corrosion on a wire terminal creates a layer of nonconductive or poorly conductive material between the wire and the terminal contact surface. Simply tightening the terminal screw compresses the corroded surfaces together but does not remove the corrosion layer. The high electrical resistance at the corroded interface remains, generating localized heat when current flows through the connection. This heat accelerates further corrosion and oxidation, creating a progressive failure cycle. Eventually the connection fails completely, causing an open circuit and control malfunction. Replacing the corroded terminal with a new one, along with stripping the wire back to expose clean copper, establishes a low-resistance connection that operates reliably without generating excessive heat. Thank you for practicing with Question Bank Hub. Good luck on your refrigeration and AC mechanic Red Seal certification exam. Don't forget to subscribe for more exam preparation content.